Hello, everyone, and welcome to Gerald and Nathan's Builders Workshop. My name is Nathan, otherwise known as Old Man Builds. We have a special guest in the house tonight. We have Sean Calderon. He's going to come on here in just a little bit, and he's going to share his ZVS flyback circuit. Excuse me, his ZVS Tesla coil circuit. Hi,
Hey,
Sean. How you
Nathan.
doing?
Doing well. Thanks for having me.
Yeah, thanks for coming on, man. I really do appreciate it.
Awesome. So are you wanting to me go through my presentation first, or do you want to have your presentation?
It's up to you, Sean. What do you want to do? Are you ready?
Yeah, I can dig in right now. So hello, everyone. It's great to have you on this live cast. I am having some technical difficulties, so my slides aren't going to be in the best order, but I'll be able to speak to them as I click on them. So what you're seeing here is my LCR meter, my signal generator, my power supply, and oh boy, I lost my picture here. Okay, can you see that okay, Nathan?
Yes, I can.
Awesome. Okay, so what you're seeing on the screen here is my test bench, and if you see that donut shaped object in the bottom, that's a toroid power transformer. And so you'll notice that there's a little bunch of wire on the right, and then there's some more darker colored wire at the bottom. What those wire strands mean is that they pick off a certain voltage from the underlying torus or donut shaped coil. And so I wanted to share this because we're going to be looking at my new ZVS circuit and how it interacts with coils like this. Okay. I'm trying to go to the next slide here. It's a little sticking here. Okay, sorry about that. Let me just go through
Is
this
there a tab to click to the right or left?
I'm not seeing one.
Go to the right side of the screen or left side of the screen in the middle.
Okay. I'm not seeing it.
You got to go.
Sorry about that.
go to the far left or right side of the screen.
Far left.
Try the right side.
Okay.
And then just go down to the center of it on the edge of the right side.
Oh boy.
I can see your mouse. You're
Yeah.
not there yet. Go to the right.
Yep.
Go to the right.
This is right as I can go.
There's no little tab there.
No. This is as far right. Yeah, it can go. Yeah, I thought the arrow would work here. Please excuse this.
It's all right. Try the arrow on the upper left side on the top.
Upper left side.
You see the one that looks like a page turn? See if that one works.
This one right here?
I can't see where your mouse is right now.
Yeah, I can't.
Sorry about that, guys. Always a little bit of technical difficulties. We'll get it straightened out here. All right. Sean popped off entirely. Hopefully it comes back right away. We'll go ahead and take care of that. Give Sean a few minutes to look it over. All right. In the meantime, what we're going to do real quick is I'm going to go ahead and pull up another video. And this is just the rodent coil that I wound. There's some wiring involved once you get it wound. Oh, hold on. Maybe it's back.
Sorry about that. I don't know. It always goes wrong when you don't want it.
Yeah. So you got your slides back up, or what are we doing?
Well, I'm going to take another attempt here. Thank you, everyone, for your patience. I really appreciate it. You're a great bunch of guys and gals for being patient with me. I'm getting there. All right, almost there. Okay. Here we go. Let me know when you can see it.
There we go.
All
We
right.
got it.
This is the next slide. 5 minutes later. Sorry about that. Okay, so in this slide, what we're seeing here is it's a small audio pickup coil. It's probably the size of a penny, and yet I'm going to connect it to the ZBS circuit and find out its resonant frequency. And this is really one of the breakthroughs that I wanted to share during through this whole presentation. And so I just start here with this picture of this little coil, and let's see. I'm so sorry. Oh boy. Okay. It's just locked up again. Let's see here. All right, Nathan, can you still hear me?
Yes, I can.
Sorry about that. I'm gonna have to try to figure out another way. Do you wanna maybe pick up on your presentation while I figure it out?
Absolutely. Go ahead and send them to my email if you can, and I'll pull them up for you.
Will do. Thank you so much. And sorry about that, everybody.
It's all right. It happens to everybody. More to me than anyone. Trust me. All right, guys, we're going to do a little bit of rodent coil on this, okay? I'm going to let Sean figure out what he's got going on. So what we're going to do is we're just going to look at it. So once you get the whole thing wound on the actual frame, then step 2 begins. So what we're doing is we're going to start identifying wires. The hard thing is when they go over it in some of the videos, you're not getting a lot of information. Like it's said, but it's not explained. So what I'm going to do is I'm going to go ahead and show you that now. That way you guys can understand it. So right here, we'll share that. We'll make it big and we will hit play. Wound your rodent coil. It's time to connect it together. Now this part looks like an absolute mess, absolutely necessary, but it's hard to figure out. At least at first anyway. It looks like a mess, right? It looks like there's no control going on here. So what is actually going on with it? Well, we've separated everything out and we have a connection from one side to the other, and we have an A channel and a B channel. It looks like a mess because there's 24 wires coming out of each bundle. Now, we need to make that 24 connections, okay? Or 22 connections and then have 2 open. So here we go. Go over to our whiteboard here, and we're going to look at this as well. This is our multimeter. All we're going to do is set this to conductivity. Now that's it right there. Now if you want to hear a sound, you'll have this one. Some of these multimeters will be together. This one, however, was not. Anytime that these 2 connections come together, you hear the sound. Make it easy for you, right? So first thing you do, we're going to go over to one of our sides. And we have them both sides coming out. Let's take a look at why. When you come out, you're going to finish. You got a side here and a side here. You got a red side. I'm going to call this side the blue side where the black tape is. Now, all we want to do is, because they're a connection, this wire loops to this wire in the end. Now, all we need to do is connect one of the wires here to one of the wires here. They're 2 different colors, but they're the same wire. I did it this way so you guys can understand it better. So, when we look at this, we are going to take the wire here. And then we are going to test it. Here's what you're going to do. And it doesn't matter which side you put on what on the colors. Touch this side here. You're going to go to every single one of these and test them. Now, the one that buzzes is the one that you want. For simplicity's sake, I'm just going to take this one here. Now, touch these 2, they buzz together. All right, now we get started. You're looking for one wire out, 11 connections, one wire out. What does that mean? We're looking for a bundle on the left and a bundle on the right. The best way to do this is very simple. Once you have buzzed these together, you know that they are electrically connected to the same wire. Now, all I'm going to do is go right here. Now, I'm going to take any one from the blue side. So I'm going to take the most convenient and best location, and now I'm going to connect it. Now, I have a connection, right? The next step is we go back to the wire over here. We can touch here. We see that they're connected, right? Now, this wire is going to go back and loop into here and come back out this side. Now, one of these is now going to be the wire that's connected in here. You see the loop? In this one over here, we go back through. We came up with this one. That's a connection. Then it goes back in. Then we're going to come back to this side and find the connection. So as we go through each one, start touching each one. See, this one is the connection. So now, going to bring that wire out. And we're going to take any one of the blue ones. Because again, it doesn't matter. We're just looking for a free wire to take. So we're going to take the best, closest one and connect it. Now we got a connection. Now again, it's going to go back through the blue, back to the red to this side. Now we can test these are all connected. Now we're looking to find the next one. See, we find it over here. We bring it in. Then again, we want any blue wire available. So we'll just take the closest best match and connect it. Now we're doing it again. So what's the actual connection? We're going to do this until we get to 11 times. Okay? That's what we're going to do. The connection is simple. It goes out this wire, comes back over here, and it goes down to here. That's the same wire each time. So now that that's connected, hopefully that makes sense to you. We have to get 11. Now that we have it all connected, this is channel A. Again, when we go through our multimeter, what we need to start to look at is this. We started off here. We found our first connection. Then we went on and connected the rest. So now these two connect. All those connections are made. Every single one of them, if you put it here, it'll buzz on every one of these. Every spot it's connected, it'll buzz. Then it buzzes to this one. That's channel A. It's done 11 times. So when we go to start channel B, where do we start? We simply just need to start again. And this time we just need any random blue wire. And we're going to start on that side. So we're going to say, okay, I got this random blue wire I like. We know that that's going to be the end of channel B. Now, we're going to take our wire tester again, touch here, touch every one of these. Well, ones that are open, not the ones that are already taken. This one was open. No, that wasn't it. That wasn't it. That. No, 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 yes. Okay, so take the one that was a yes. That's where we're starting. Okay, now this is going to look a little haywire at this point because now, once we get this and we know that we're electrically connected from B to B, now we need to pick a blue wire. Go straight over, connect right there. That's our first connection. Now, what do we need to do then? Again, this is connected to here. We now need to find where this ends up over here. So we'll test it again. So we'll simply take the one that tested, Now, I need a random blue wire, so I'll take the best available match, come straight over, and connect it. Right there. Now, again, we're looping in a system. So the system goes in through this one, back through this one, in through this one, back through this one, continuously. Now I need this to be the same thing as this. I need 11 times. Therefore, I'm going to test it all out until I get to the 11 times. Now that you see everything drawn, it looks like an absolute disaster, doesn't it? But it all makes perfect sense if you simply follow the directions in the beginning. You want a wire that comes from this side, goes back around to this side, and then connects. This is why it's not explained a whole lot. So let's get over here to this. You could see in here that we have a lot of wires connected. So let's see if we actually got what we wanted. Make sure our tester doesn't mess with us with the battery. And then we're going to take each part. Let me see if I can't get you a little closer in depth. So now, I have this wire here pulled off. This is where I started. So every one of these, every time I touch them, now they're all connected. Now here's my last one. Now I have a channel. This is my channel B. As you can see, we'll do it again. It looks kind of hard to see. See if I can't get you a better look. We'll turn these up a little bit. And you can see they're all wired together, just like we wired it on the board. I didn't solder any of these yet. Let's see if they're all right. We started here. Yep. Now that's one complete channel. So we have the same thing done on this side of the wire. That's channel A. That was my channel B right there. That's why it looks like an absolute mess. Follow what I said on the board from the beginning. Start slow. One wire on each side. What I like to do, as you can see it right here, is I pin them back. You see these two wires right here? I pin one back and just tape it. And then I test them all. And when I get done with all the 11 connections that I have right here, come back and I take this last wire and I put it right next to the beginning wire. That way I know this is my channel A. Between that one to that one, it's all electrically conductive through all 11 of these connections. Channel B, here's our two wires right here, all electrically conductive through all of these. That's why it's hard to understand. Hopefully you guys get it. Hopefully I explained it well. But this has been one of the most confusing things that I had to look at because they generally skip over this. Take your time and test them one by one and you'll get through it. If you have any questions, let me know. This is going to be something that you're going to have to be patient with when you get the answer, because if you don't understand what's going on right now, it's going to be kind of confusing. Hopefully one answer will clear it up for you. If not, you're going to have to watch the video again. Anyway, hopefully this helps you out. And if you got any questions, just let me know. Thanks, guys.
Are you still there? Seems like you're muted.
Hey, Sean, how are you?
Hey, how are you?
Good, good. A little late, but you know, I was told I'd be late to my own funeral, so
That's a good thing.
I think so.
Yeah, so I had some technical difficulties earlier, but I was able to get you the screenshots and videos if you're ready, Nathan.
Nathan, you're muted.
Yeah, he's still muted.
Sorry, guys. Yeah,
There
my
you go.
fault. I
No
keep
worries.
clicking the mute so you don't hear me in the background if I sneeze or do whatever.
Yeah, I do that when I
Sounds
cough.
good.
So, Sean, where do we have him at?
All right, so I gave them to you in Messenger. Can you see them?
Give me 1 second. Let me pull it up.
Okay. So you just getting off work, Gerald?
Yeah, just getting back from doing the cooking.
Okay, cool.
Yeah, I had to do vegetable soup and beef stew today. So
Nice. Nathan made dinner for his family, and I'm also the household cook. That's interesting.
yeah, this was for 150 people, but yeah, I do the household food too. Fortunately, tonight I'm gonna enjoy spaghetti, and I'm not cooking. So
Nice, nice. 150
Okay.
people.
yeah, I do catering.
Oh, okay.
Yeah,
Hey,
I do catering on the side. So sorry, Nathan. Go ahead.
No, I'm sorry, guys, to interrupt your conversation. You sent him in a emailed folder, so I don't have an email password to get in there.
I'm so sorry. It said it sent them to you. Oh boy.
Yeah, it sent it, but when I clicked on it, it still gave me put in your password to open it up.
Just the password?
Yeah, you know what, Sean?
Yes.
We'll just pull them up one at a time. So just open one and pull it up, and we'll just take it slow. We'll get through it. You know what I mean?
Okay.
Pick the main ones that you want, and let's just do that.
Sounds good. I appreciate that. Okay. Let's do that. So I'm going to
Before
pull
you
up.
start, I got one quick question. Can you guys hear the background fans that I'm
I
running?
don't.
Okay,
No.
awesome. I'll shut up. Please go ahead, Sean.
No worries. No worries. So going to start here with the mighty ZVS. We've talked about that before. And from Amazon, I ordered every kind of ZVS circuit in order to really dig into their capabilities, their power requirements, and just learn about them. And so these are the main ZVS circuits that are sold on Amazon. And so I wanted to share that with you, is that I'm really digging deep into these ZVS circuits to figure out how can they best meet my needs for creating high voltage circuits very efficiently, yet lots of plasma. So I'm going to go to the next slide. Can you guys hear me okay?
Yeah, we can all hear you. I just pulled
Awesome.
this out so you can present.
I appreciate that. All right, so I'm going to go to the next slide. It's about 20 clicks to go to a slide, so please forgive me. Okay, almost there. And let's see. All right, so now that you've seen all of the ZVS circuit configurations from Amazon, here I scoured the internet to find ZVS circuits that were designed by YouTubers or other people on the internet that are designing their versions of the ZVS. Now, primarily ZVSs are used for induction heaters. And so you'll see a coil sticking off at the end of a ZVS circuit. And then if you put some piece of metal in the coil, it'll begin to heat up and even melt. So that's the primary purpose for ZVS circuits. But what I've done here is I've acquired their Gerber files. I sent them to a PCB company who printed the circuit boards for me. And then I ordered all the components that were necessary for each different circuit board. And as you can see, one of the circuit boards I've actually already soldered together and I'm using it for testing. But these were all I could find for free on the internet. And so I just wanted to give you an idea of also how I'm really shaking the tree to get all of the ZVSs that I can find that are used, both mainstream and niche. Going to my next slide. One of the key differences in the ZVS that I am using is this little portion right here. So a ZVS circuit usually has resistors, diodes, and MOSFETs. In this, what you'll see here is there's an extra resistor for the MOSFET here to the right, and you'll see that the resistor has the number 47 written on it. Number 470 is also a resistor, but that's the one that usually comes with ZVSs. So the 47 ohm is an addition, and then you'll notice too at the right of the two resistors is this little blue circle, this little blue oval, and that's a capacitor. Now, this little extra functionality here ensures that the feedback diode works properly when applying power to the circuit. So the tricky thing about ZVSs is that they're difficult to start oscillating. And the reason for that is that the diode doesn't work when you first turn on the power. It's sort of a hit or miss. So this little additional resistor and capacitor ensure that that diode turns on always, ensuring that the circuit always oscillates. And so this is what now makes this ZVS very flexible. It doesn't have these sort of finicky, pull your hair out, wish you were never born experiences when trying to get it to oscillate. This addition to the circuit ensures that it oscillates all the time. And so we're going to see the benefits here of having a ZVS that oscillates all the time. So now I'm going to share a video here real quick. You can probably hear it as I'm selecting through. Almost there. Okay.
Hey, Sean, I don't have anything to pull up there.
Yeah, for some reason it doesn't want to show the videos. Sorry about that. I'll shut the videos down. We'll just use pictures. Okay. So I'm going to go to the next picture here. And in this picture, if everything works, is going to be of the signals that you can see on the O-scope. And so when I connect the coil to the O-scope, I can get the resonant frequency pattern. But to find the resonant frequency of every coil requires a lot of work, a lot of technical calculations. But with this new ZVS board, I can connect pretty much every coil I have on the bench, and it will give me the resonant frequency automatically. I won't have to perform calculations, find capacitors, and then hope it works. Here you're seeing the resonant frequency of a tiny coil that I had, a pickup coil that I had on my workbench. And so I'm going to show you a few more different patterns. But the beauty of this ZVS is you can just connect it to pretty much most devices that have capacitance or inductance, and then you'll immediately be able to jump into its resonant frequency. And that opens the door really for a lot of different experiments. In fact, I read a physics journal that said that every object in the universe has its own natural resonant frequency. So this ZVS here is going to be an instrument to try to peer into what are the resonant frequencies of the objects that have capacitance and inductance around us. And also too, everyone has capacitance and inductance. Now, I'm not saying you could hook yourself up to the ZVS and find your own resonant frequency, but you could pretty much test most components. And also, I'm going to start experimenting with finding the resonant frequency of magnets and certain metallic geometries and so on. So it's going to be pretty exciting. Go to my next slide. Thank you guys for your patience. Hopefully the long time between slides is giving you time to contemplate what I'm sharing with you. Let's see. One of the other projects that I'm working on is a very specific shaped Tesla coil. And so what you're seeing here is a 20-pound spool of 33 gauge magnet wire. And I've placed it on my counter here. It's on a turntable of an old record player. And if you look at the bottom, you'll see two half shapes that make a donut. And what I'm doing is I'm wrapping around between 175 and 200 turns of wire per groove, as you're seeing in this toroid shape. And in the end, I'm going to be setting in an epoxy tomorrow and getting the bubbles out using the vacuum chamber. And then this will be now a toroid Tesla coil. And so as you've seen in my other presentations, the sphere Tesla coil you guys found fascinating. I'm expecting this one to have its own fascinating facts that might surprise us. Okay. Let's see if we can get a peek into one of my new coils. Okay. So this was one of the coils that I had shared in my presentation of the sphere. This is my 6-inch coil, and it has 5,000 turns of that same magnet wire. And I'm putting in about 40 to 50 volts AC. And every time you hear the sound change is I'm adding different voltage levels. And so not bad in its preliminary testing. And this is using the new ZVS board. Now, this is about a third its capability. I'm still pretty off on the tuning. So I'm looking forward to seeing these plasma discharges double and triple. And when they do, I'll be happy to share them with you in future presentations. Okay, I'm going to show you just a couple more slides and videos. Let's see here. This is an inside look of how I'm winding the coils that I wind that have the deep grooves. So here's a close-up of how each groove is wound with between 175 and 200 windings of copper magnet wire, 33 gauge. And so you can kind of get a sense of once I finish filling up one groove, then I drop down and start forming the next groove. And then I drop down and you can see that diagonal line that connects each group. And so each group of windings acts like a high voltage coil. So when I fill in this with epoxy, the epoxy isolates every groove, which acts like a high voltage coil. Yet when electricity is applied to the coil as a whole, each groove acts like one giant high voltage coil. And that's where Tesla coils can get their giant arcs and sparks. And so here's a little drill down picture of that, what I do when I wind my coils. Let's see here, almost done. I know there's no rush. You guys are very patient. Let's see here. That one didn't quite work. Almost there. Let's see here. This is the one. Okay. Something's going to come up to the screen here in just one moment. I'm getting good at clicking. Let's see here. All right. So when connecting to one of the coils on my workbench, this is how the ZVS works in determining the resonant frequency and displays the various patterns that are unique to the geometry of the object that I've placed to measure. And this is as I'm adding voltage. You can see how the waveforms are, what we're getting is resonant frequency. We're getting resonant frequency reflections. So when you see what looks like it's flashing from right to left, those are the reflections because the signal should be moving left to right. And so that's the unique waveform, the resonant frequency waveform for one of the coils that I have there on my workbench. And that's just an example. I was having fun just exploring the different waveforms for the geometries that I had on my desk. And if I didn't have to leave on vacation, I would have had a lot more video to share. But I'm going to show you just one more, and then we'll be complete here. Almost there. Let's see. Okay. And this is just another waveform. You can see here the reflections going from right to left, but the input signals are going from left to right. This is another example. And that's pretty much it. I didn't have a whole lot to share, but I wanted to give you an update of what I'm working on and just be available to answer any questions that you might have. And again, thank you, Nathan, for having me on.
Right on. Hey, I do have a question. That
Sure.
resonance frequency. You kind of talked about it, but I want to make sure we all get how that works because you're pulling it right away where we don't have to go through the dial or anything on our signal generator.
Right.
So can you please explain that just a little bit more?
Sure. So when you connect a coil with a capacitor, the coil's inductance and the capacitor inductance, their values are going to determine a resonant frequency. So for example, okay, so let's think of a capacitor and an inductor as resistors, okay? You know how a resistor has resistance? Well, capacitors and inductors also have resistance, but it's not called resistance, it's called reactance, you know, to make things more complicated. But the reactance is measured in ohms, which makes it even worse. So if the capacitive reactance is the same as the inductive reactance, then all of the resistance is canceled out. And therefore, you have the least dampened signal. Now, with perfect components on your calculator, current reaches infinity. When reactance of the capacitor and reactance of the inductor are the same, they cancel each other out, reaching infinite current. But because inside of the little copper wires, the little imperfections, there's resistance in the copper wires, there's resistance in the capacitor and the inductor, what you have is that infinite current taken down to a massive amount of current.
Okay.
And that massive amount of current gives us that plasma discharge. It gives us those big sparks. It gives us basically that high power of current, because it's a current resonance. We usually only deal with current resonance. We don't deal with voltage resonance. And voltage resonance, I'll have to do a whole nother presentation on, but that's not what I'm showing you here. And so that's what you're seeing. And so, for example, now, because the ZVS is really good about oscillating, I'll put in a capacitor and then I'll grab some coil off my bench and connect them up in series. And then their capacitance reactance immediately cancel out because of how the ZVS oscillates. And you immediately have the resonant frequency output. And that's what's giving you those sparks and arcs. Did that make sense?
Yeah, that's so cool. What do you think, Gerald?
Yep, I agree. Not only that, go ahead.
Go ahead. I was just going to say it's the fastest way we've ever seen to get it.
Yeah, you know what? I was having a bit of camera problems there while I was downloading something, and I missed the first waveform. The second waveform I completely recognized. So I understand which way you're going with resonance, but I wonder how many different ways there is to achieve resonance.
That's a great question, because resonance, as it relates to objects in the universe, is usually related to vibrations.
Yep.
What we're doing is electrical resonance, which is still vibrations, but we call it electricity, and we call it AC. We call it DC, because the electrons are vibrating. So it's all vibrations. And so if you think about, I love the best description for resonant frequency, or the resonance of every object in the universe. It's the least dampened signal that works with that object. And so we're all right now vibrating at different frequencies. But if a certain frequency hits us that's resonant, it means it'll have the least restriction, the least hampering, and will have the maximum amplitude and maximum energy. Does that make sense?
Absolutely.
Yeah, I love that description.
I just got a new miniature handheld oscilloscope, and now I could see both my signals. My mind is blown.
Wow, that's awesome.
And yeah, I'm seeing things I never thought I'd see before, and where resonance is and how high I could go. And I don't know how high of a frequency is an average for resonance. Like, does a Tesla coil resonate, say, at 1 million, like a megahertz?
That's a great question. So the rule of thumb about resonance is the lower the inductance, or the smaller the coil, the higher the resonant frequency. Okay. The lower the capacitance on the capacitor, the higher the resonant frequency. So when you wrap a little tiny Tesla coil, it's going to have a low inductance, so it's going to have a high resonant frequency in the megahertz. When you have a taller Tesla coil, it's going to have a higher inductance, so it's going to have a lower resonant frequency. And so Nathan and I have been sort of focusing on that 100 to 500 kilohertz range for our Tesla coils. And I know the 300 kilohertz is a resonant frequency that Nathan likes to work with the Graviflyer. So those are the rules of thumb. And I pulled up the tiniest coils, and I can get about 28 megahertz resonant frequency, but that's as high as my oscilloscope will measure without a lot of noise. Now the lowest resonant frequency is, I've gotten it down to 5 kilohertz, but I really want to see if I can get it into the hertz. That would just be fascinating.
It's scary when you
in
do.
the hertz.
And there's reasons like so how do I put that? Because I don't want the channel to get dinged, I can't explain what happens at low hertz in certain coils. Does that make sense?
Yeah.
Because it directly affects you if you have a spinning magnetic field and you're close to it and it's at a low hertz.
Uh-huh.
And I can't say anymore.
I can tell you how to get there, Sean.
Yes.
You just have to add mass to a wire and put it down the throat, and it'll reduce your resonant frequency. So you can go down pretty easily to the single or double digit hertz if you want to by doing that.
I didn't know you could do that.
Sounds fascinating.
That's awesome.
That's how my Graviflyer Tesla coil works.
Well, I know you're dropping your frequency because of that. I just didn't know you could go that low.
Yeah, you could drop every one of them down low.
I'm trying to figure that out in my head, because if you're putting it down the throat, frequency goes down, correct?
Yep.
So frequency goes down, that means you've increased your inductance. So how are you increasing your inductance? By placing that wire down the throat of the coil. That's fascinating. I really have to figure that out.
Well, that's kind of one of the keys to the Tesla coil on this thing.
Yeah,
depending on which coil you put into it, that number gets lower and lower. So you have to kind of watch out on some of it.
Yes, that sounds interesting. I've never tried that, and I'll tell you, I've researched Tesla coils a lot. I suffer with my health problems, so I'm on YouTube a lot.
Same thing.
What you've done, Nathan, hasn't been done. So I have to really dig into that. That sounds fascinating.
What Nathan has done, I've asked questions multiple times. You see pictures of Tesla at Colorado Springs. There's a pole that comes up the center of his Tesla coils when he's in that big round one that he built for Cliff. And I asked everyone that I could, what does that mean? The only one that knew was Nathan.
Oh, that's interesting.
Yeah, and he used it to the best of his ability, and I just love that because nobody knew what that was for.
We're gonna start putting light bulbs in the ground now.
Yeah. Oh, I just watched a documentary talking about that. We should get into that later.
That's fascinating.
About sonic waves and surface waves and interesting stuff. Anyway, I'm sorry to cut you off, Sean. Go ahead.
Not at all. No, I'm glad you're keeping the conversation going and interesting. I appreciate that.
We're gonna have to see what Mike's up to, because it looks like he's out there painting stuff.
I was just gonna say that he's giving us a little video display from his vantage point.
His secret locker in an undisclosed location.
That's right. That's it. The Bat Cave.
Yeah.
And he's got Pepsi. That's all you need, man.
That's right.
That's it. You got it. So just kind of a continuation from yesterday. I'm fabricating my plates. So I'll show you what I'm using to fabricate the plates with.
Wow.
It's the carbon ground spray. So I'm fabricating all the plates with the carbon ground. I also have another fabrication process that I'm working on too, but I can't really talk about that because I haven't finished it. So I'll talk about that later when I actually finish it. Okay, these are the nuclear grade carbon graphite. This stuff is, right here I got about, I think 27 plates plus what I have on the ground. It's over about $1,500, almost $2,000 worth.
Oh,
Beautiful.
wow.
they put this in nuclear reactors to cool the core. So my friend or my partner that I'm working on the project with, he knows the guy who's the main distributor of this material for Ontario Nuclear. So
Awesome.
we have our source of getting, like high grade, like these plates are
Awesome.
gorgeous.
I want some.
Yeah.
Well, one sheet is 39 inches by 39,
Yep.
and it's $280 Canadian each.
Whoa. Whoa.
Nice.
Yeah. $280 a sheet.
Is it graphene or graphite?
Pure graphite.
Graphite. Is it paralytic graphite?
It is, it's built for thermal, but it's also super electric conductivity with it. It's very high
Wow.
grade. It's very, very high grade. You can't buy this on a regular, you can't go to like the regular Amazon or whatever and order this stuff. You can't get it from there. We're actually getting it from the main distributor for Canada. So, yeah.
Are you using them for power? For
Yeah, he's
heat
making
dissipation
solid
or
state
for
Well, what it is, it's a crystal power cell. It's kind of gone way beyond what John Hutchison did.
Yep.
So what the graphite does, it absorbs that charge. It's basically the capacitor of the cell.
wow.
So when you create your redox reaction inside the cell, that charge fills up these plates with the charge. And that's where you get your 14, 15, or 30 amp spikes from
Nice.
these plates.
What goes in between the plates, if you don't mind me asking?
That I cannot discuss,
And
unfortunately.
that's what I know what you're. That's
Yeah.
all I'm gonna say.
Yeah.
He's
There's several-
a very smart guy.
I've solved a problem that a lot of people have been trying to solve for a very, very long time with magnesium as a donor plate.
Mhm.
So when magnesium activates, it's a very reactive metal.
Yes.
It oxidizes. Okay, I
Yeah.
found the agent that neutralizes it. So when it does oxidize, it tries to oxidize on the surface, but what happens is this agent destroys it right away.
Hmm. Is it
And
magnesium flammable?
As soon as you go above 800 degrees, yes, it's extremely flammable, but these cells don't heat up at all. Not even close to that. They don't heat up. They do have a thermo-electric reaction where they could actually, if you put your hand on the plate for a couple of minutes, the voltage will actually go up. So there's actually a thermoelectric conversion also happening in the cell. The cell also has another interesting attribute of the cell. When you're not using it, the way it's designed, the way I've designed it, and the way Michael Kantz designed it, the cell will actually go into a sleep mode. So it doesn't use. So the reactance happening on the donor plate goes to zero. The second you put the load back on it, it comes alive again.
It's amazing.
Can I ask
Yeah.
a question? You don't have to answer, of course, because you got a thing going on. But when you put your load on, it's not unlike pulsing your cell that gives you back your power. Am I wrong?
Like a back EMF you're talking about?
Yeah.
No, it's not that quick. It's a steady climb in current and voltage. So when it goes into sleep mode, it will start bouncing back within a couple of minutes. It's back up to full power. So
Amazing.
the sleep mode is very good because if you're not using it all the time, you don't want to waste the donor plate and you have the donor plate deteriorate, right?
When you start putting these in production, I want one. I'll pay for it, but I want one.
I think we all want one.
Yeah.
Yeah.
I'll come pick it up.
You know what? Nothing of what I put in it is a secret, but the way I put it together is intellectual knowledge.
Yep.
That's how most great experiments or inventions are. It's lying all around us. It's just the
Right.
genius of putting it together.
All you have to do is solve the problem with the donor plate. The second
Wow.
you find the agent that neutralizes oxidation when the reaction happens, that donor plate will last for years. So Michael
Mm.
Kantz from Quantum Magnetics, he had a YouTube channel. Unfortunately, he passed away in 2022. He
Mm.
had a provisional patent on his cell. So whatever literature, whatever videos he had, me and my partner for the last probably 4 months have been trying to decrypt how he built it. And we're very, very, very close to what he did.
What are you hoping to be your first use case once you have these ready
Well,
for production?
Well, I got these. I got 3 4-kilowatt inverters here from Canadian Tire. I got one here and 2 down here.
Ah, yes.
So what I'm going to do is hook up a bunch of batteries to run the inverter, and the cells will be on a charging circuit that controls it. Charging is actually part to do how this cell works. That will attach to the charge controller. Charge controller charges the batteries. The batteries power the 4K inverter.
Nice.
Nice.
So this is house power. You know, you could hook up anything to this.
And it doesn't
refrigerator.
need to be outside or in the sun. It could be inside. It does have
It can
fumes?
be in your basement. It could be 10 feet below the ground. It'll still work.
Oh my goodness.
So what you basically did is, if it was the equivalent of a lead acid battery, you solved the sulfation issue. And
Yes. Yeah. Pretty much.
I get exactly what you mean.
Yeah, you could take that agent that I have found, probably put it into a lead acid battery and completely restore it. Now, if it's over oxidized, like really bad, you might have to hook it up to a Bendini motor and restore it. And then after you do that, then add the agent to the lead acid battery. And also the agent's actually completely non-toxic at all. You could actually consume it, believe it or not. So there's a hint. So, yeah. So yeah, these plates are amazing, man. They're like,
so what's the expected mass of the cell?
well, these plates are 12 by 12, and when they're done, they'll be about a 1/2 inch thick. So I'm planning to make 20 cells.
Fascinating. That is so cool. Will you be able to give us a demonstration if you hide the secret parts?
Oh yeah, I'll demonstrate it. Yeah, sure. I did a demonstration yesterday with my little micro cells that I built, and they've been running for 2 weeks straight, charging up a 100 farad super cap bank and sustaining it. And the second I put it into a sleep mode, go back 5 hours later, start it up, she's full power.
Amazing.
It's sustaining the voltage and the current.
Wow.
I did one test on the weekend with my partner. We were sustaining 14 amps pulses.
That's powerful. Do you have an idea of what the efficiency is? Have you measured that?
I haven't even gone that far. We have to get the big ones made in order to really determine that. Like I know those small cells that I did build calculated how many watts per hour in 1 month, and those tiny little cells produce 4 kilowatts of power.
Wow.
In a month.
Wow, that's amazing.
Yeah. So
thanks for sharing. That's great.
Yeah, it's coming along. It's going to take a while, a lot of testing since we get the big ones built. We might have to do some changes. We don't know yet, but we have a pretty good idea of what's going inside and how we're going to do it. The little test cells are proven to be very encouraging as far as results are and longevity. I had my first set that I had running, and it didn't have my secret agent in it. It ran for 4 months before the donor plate crapped out. Now I got that agent in there that protects it from oxidation. Now it will run for God knows how long. So the donor plate is going to be 8 inches by 8 inches relative to the 12-inch plate. So that's how big the donor plate's going to be.
So what are the tests? What are the tests that you're performing on it?
Right now it's just voltage and current. So we put the cells in like we call it a duty cycle. So we would pulse or put a load on the battery for 2 seconds, and then it will shut off for 8 seconds. Let it build up the charge, then pulse for 2 seconds, and then rest for 8 seconds. And if you keep that rhythm going, you will never kill the cell. You'll never draw the voltage down. It bounces back.
Wow, that's fascinating.
So that's a very key component to how these cells work. Michael Kantz made it pretty, public on how he was doing it. So we're just trying to follow. We're just trying to follow his footsteps, what he did, to the best of our knowledge, because he's dead now. He's gone.
Yeah.
So he was cryptic when he did do some stuff online that we were able to find, but he was cryptic, so we had to kind of decrypt it. What he was talking about, right?
Right. Do you have any of his papers or anything?
Everything's online. Yeah, just his videos, even his videos too. If you watch his videos, he's really cryptic in what he's talking about, so you almost have to watch the same video 10 times to really get it, to get it, right?
Makes sense.
So, yeah, I think we're homing in onto it's pretty close to what he was doing. Maybe not exactly, but pretty damn close. Yeah.
You made mention of a non-disclosure agreement. Are you looking for a patent? Has it been submitted, or what's the status?
We have other avenues how we're going to release this. We're going to kind of release it through the back door, so to speak. We're going to hit certain industries, which my partner is pretty much setting up, and also financing and stuff like that through some financial guys that he's hooked up with that could help us out greatly as far as, taking it to the next level.
Wow.
Who our target market's going to be, stuff like that. So that's all been discussed. So I can't really talk about that stuff, but I'm more. Go ahead.
Sorry, you're doing this as part-time because you have your day job, right?
Exactly.
It's amazing.
It's like 7 o'clock at night. I'm outside of my storage locker.
Wow, that's awesome. Good to see your commitment.
Yeah, well, I have to do this stuff outside because some of the stuff I'm using, the carbon spray that I'm using, they have some kind of aerosol in it, and it friggin' reeks like really bad. So stuff like this has to be done outside, otherwise the wife will get really pissed.
Is that a truck trailer?
This is a storage. It's a shipping container. It's 25 by 10, I believe.
Huge.
So this is all my shit.
Smart. I'd be locking it up.
I just don't have the space at home, and if I have to fabricate stuff like this, I have to do it outside, right? It's just not feasible when you live in an apartment. So
it makes sense.
Well, down the road, I think if we get the financing we're looking for, we might open up a small little shop in my hometown. And that's where all my R&D is going to be done. Building, all my fabrication will all be done there. So,
do you have an idea of what you're going to call it?
Well, everybody, calls it the crystal graphite power cell. So it's going to be something along that line. Yeah.
Yeah.
Don't know yet.
Expect to have enough production where you can quit your day job?
I'm hoping by this time next year.
Wow, that's awesome. That's great. Inspiring.
Yeah, I'm pushing hard towards it. This is all my little free time I have right in the evening. Oh, Jeremiah. What's up?
Sorry, I just need to step away for a minute. That's all.
Oh, yeah. He wanted to tell us that he couldn't talk.
What's that? Go ahead.
If you open a shop, Mike, I'm coming down there. I'm telling you right now.
Hey, you have no excuse. You live in Canada, so you don't have to worry about crossing no border, eh?
You ain't wrong. Well, I don't know. Ontario and me, we have a history. Okay?
Yeah, just don't worry. The Trudeau followers are dwindling now. So, you should see. You should see all the protests. Shelburne, Toronto, Brampton. I go there. There's friggin' riots on the friggin' street. You know, F
Oh.
Trudeau and yeah.
It's like
Oh,
my
yeah.
dream come true.
They really do not like him.
Yeah, finally they see the true him.
Yep.
They
about
find
time,
you a
huh?
long time ago.
Yep.
He hasn't changed one bit. See,
So,
now hopefully.
Gerald.
Oh, okay. Sorry. Go ahead.
No, Gerald, you were showing us some what looked to be some components and wiring.
Oh, Gerald's done some
You don't want
homework.
to see that.
Yes, we do.
Just kidding. Hang on. Get my ugly mug out of here.
So, anyways, that's my my little presentation. I'll take
Thanks,
my bow.
Mike.
Thank you, Mike. I really appreciate it.
Yeah, I'll. Are you guys gonna be on longer? Or?
Who
Probably
knows?
for a while, yeah.
All right, I'm gonna sign off here because I'm outside, so I'm using data right now. So, yeah,
Okay.
I'll.
Great
I'll
job,
chat.
Mike.
Yep. Okay, I'll
Awesome.
hook up with you guys later.
Later, Mike.
Okay. Cheers.
Cheers.
Okay, I got a quick question. I know Gerald's got a couple circuits, and then Jeremiah, did you just have one?
We were talking about ZBS earlier, and I've miniaturized some ZBS circuits, so I was just going to show one example here.
Yeah, he can go ahead. I can wait.
So this is a simplified circuit. It takes a infrared input here with this IR sensor, and that allows you to control pulse width modulation on this little ZVS coil driver. And so these are the components that go into a ZVS and portable voltage multiplier running that circuit. It's incredibly small. Here's your little IR sensor. And when it's all put together, it's just this little tiny board. Now on the other side, the rest of the components. So this is an example of an earlier version. And what's neat about these things is they're ultra responsive. So most ZVS, they have a limited frequency input. They generally crap out above about 70 to 100 kilohertz. And if you get them to operate in higher frequencies, they're generally operating class E, so they don't have enough push-pull current for the MOSFET gates. This will show that we found a way around that. Do you have audio? Did you get audio on that?
Yeah, do you mean shut it off?
No. I was just making sure that it was actually coming through. That's all. This is what it's doing. So it shows that we can pulse width modulate the output of a voltage multiplier that has the correct output impedance, which normally voltage multipliers you think of, you want steady state DC. Well, in this case, they're specifically designed to generate AC, very high potential AC. And in this case, I think this one is like 68 kV or something on those lines. But we miniaturized the entire thing, and here's what it looks like. This is one of those micro miniature transformers. This entire transformer and the resonating capacitor for this ZVS, they are like itty bitty. Okay.
Size of your fingertip.
Yeah, exactly. And so they'll pump. I've been able to get 40 watts of pulse power out of them, and about 10 watts of continuous power for sustained periods of time. They're 20 watts average. And so this is what the arc from one of those little transformers looks like, and you'll just be able to see the power. It's practically a welding arc. I'm just pulsing it because if I leave it run for any longer than that, the terminals will evaporate off. But the transformer has no problem pumping it. So when you connect that to a little voltage multiplier circuit like this one here, you end up getting this. Here is the miniature 10 gram, 88,000 volt, 20 watt power supply. I have it hooked up to a static power supply, which is simulating 2 dead lithium-ion batteries right now. And zooming back, the output of that high voltage generator is hooked up to this ion air cleaner. So this will give us a thrust simulation. Right now I'm going to optically stimulate the circuit, and this is what its output looks like. So here, that controller that has a green LED underneath my palm It's just got an infrared LED output that's pointing into the circuit, and so the optical sensor is picking that up wirelessly so that there's complete isolation between the power supply and the driver.
Is
It's
this
like an
for your
optical
voltage one?
isolator?
It is what?
Go ahead, Sean.
Is it an optical isolator?
No, there's a photo sensor. It's a tiny little solar panel that's encapsulated in epoxy, and it's a conventional commercial component that you'll generally find inside of a laser galvanometer or something on those lines. And
you're using that to isolate yourself from the high voltage?
right.
Awesome.
Yeah, so
Very
it just
cool.
uses a little LED. You can effectively send it across the room, or if you used a more focused beam, you could send it, I mean, hundreds of, miles, realistically, if you wanted, but depending
Super
on its
cool.
sensitivity too. So the idea is, remote control by line of sight. It's not ideally remote control, but it at least isolates my driver circuit so I can input the same PWM signals at a square wave with very sharp edges, and I don't have to be in physical contact, which means floating circuits.
That's awesome.
This little tissue paper here is just sitting on the back of the fins for this air cleaner assembly, and it's all being powered by this little voltage multiplier here. You can see it's frequency variable, so I can have thrust control simply by PWM modulation and audio range.
Wow. That's cool. And it's ion wind.
All in all, it's basically ready for integration directly into some kind of glider or ultralight airframe. And all it needs is simply that frame to work with, so I can adapt the electrode plates and create the ion thrust mechanism on that airframe. So this gives you kind of an idea what I'm looking for. We just need something very light to put it inside of. So I did end up actually building that ion airframe. I have to stop here now. And I've got an insanely light 1 meter glider. It's like 20 something grams, the entire glider. And that power supply only weighs 11 grams now with the wires.
Nice.
And battery packs don't weigh much. So, I mean, realistically, it could beat out MIT at a 5-to-1 ratio. I'm buddies with Ethan Krause, who is currently the only guy who's achieved self-sustained and integrated ion lift with its own onboard power supply. And he owns the company Electron Air. And we've had, many great conversations. He's really optimized in terms of miniaturization, the high voltage power supply and the CBS module. And, we've kind of traded off ideas, and both of us have done a huge amount of work making these things uber super tiny. So
you've made like high voltage pens and
yeah,
wands,
right.
and I've seen those before. You're really good at miniaturizing. That's great.
It's fun, right? The challenge is, if we want something to be pretty close to magic, we need to be able to pick it up and carry it with us. I understand I'm all for big bench rack mount power supply units, and you got nice 6 UHV racks from Spellman and whatnot. But if we really want the magic, we've got to be able to carry it around in our hands. And
yeah,
that's what we're working on optimizing is making this stuff portable, because ultimately along boards of a spacecraft, it's got to fly. So no reason to carry extra mass with you.
Yeah, thank you for presenting. That's very interesting. Awesome.
It's very cool. I like it. I like that little wand. That's my favorite.
Yeah.
Well, which one? I mean, let's see. We've got a bunch of them here. I'll just pull up a few.
Didn't you guys sell them at one time?
No. Everybody asked us to sell them. We can't sell them, and I'll tell you why. Okay, so this one will do 130 kV.
Wow.
This one will do about 100 kV. Though technically it can do 120 kV. But this one is positive output and it's pulse. This one is negative output, and it's the one I showed in the video. These are safe enough on their own, and to demonstrate that I can, so I can hit myself. It's not going to stop my heart. It doesn't have enough current. it's resistor limited. But here's the problem. Imagine I sell these. Little kid goes up to grandpa and says, "Hey, want to see a magic trick?" And so these make feathers levitate and oils float around, all kinds of stuff, right? So he's abs grandpa. Grandpa's got a pacemaker, but grandpa's standing on a tile. He's standing on a linoleum tile in the kitchen. Okay, so little Johnny charges grandpa up to 100,000 volts.
Yeah,
which is the
capacitor.
faucet, and what happens? Right. So that's the problem. These are not dangerous. What they can do in terms of building up charge, that is dangerous. And I'm just, I understand that if this gets out there, like it's basically like any kind of drug or anything else that you're going to do when you have to reach a certain age. We've validated in society that you have to be of a certain age to have the social responsibility to know how to consume something or use something or, drive a vehicle or operate equipment. And this is one of those pieces of such equipment.
Yeah. Like a taser or something. It's almost like a firearm.
As wonderful as it is. And you can, if you're a responsible parent, you can teach a kid how to use that thing and not build up capacitance. You can show the demonstration of doing lightning craft and basically making 1 foot lightning bolts with that little handheld thing.
That's amazing.
You want to make sure that they understand, don't harm people accidentally, right?
Yeah.
Or yourself.
Yeah.
It's some pretty good times. I know both, we can all share about that. I've been doing it, 24 years now. So
Sean set me up. He sent me this little wand thing in the mail, right? So I used it, put it on my beard, man. It absolutely zapped me. Yeah, me comb my hair with it, zapped me again. Yeah. He had the greatest time laughing at me. He made a little mini Tesla coil out of it, but he got me.
Oh, I should. I mean,
have you got the pointer for it?
Oh, look how small that is.
That's another thing. You and your friend are really good at miniaturized Tesla coils.
Well, I mean, we did create the circuits for them. I mean, they're all over the internet. A lot of people have copied them. So
I was going to say, you have a lot of different really cool designs, miniature designs. I mean, even the top load is unique. The coiled top load is really fascinating.
Oh, we kind of copycatted this. This top load here is just this full wire and. Geez, who was it? So I think I first seen this on Electric Boom. So here's the thing. Electric Boom copied my Electric Magic Wand. He really wanted one, but I wasn't going to give him one. So for his 4 million subscriber self-reward, he built himself one of my Electric Magic Wands, but he didn't do a very good job. So it only has about 1/8 the power output of mine, which is a shame because he could have done a lot better. It's not that hard to fit the transformer in there. And I'll tell you, the real secret here is the transformer. And you can see it. And I've left this clear so I can kind of show this.
Yeah.
And this power transformer is not that particularly large, but that power transformer with the mashed impedance driver, which you can kind of see the inductor in the moving towards the back here. Okay.
Yeah.
You get all those circuits matched up and they'll go into resonance. And so this has a much higher output potential than you would expect from a transformer that's basically only as wide as 1 digit of your pointer finger.
Right.
And
you said it's impedance matched? Is that what you said?
Yeah, it's impedance matched. You got to treat this thing is matched like an RF transmitter.
Yes.
And the antenna that it's going into is the multiplier stage that runs along the stem here of the wand.
Okay, makes sense.
So Electric Boom, he doesn't really understand that, but he copied our design. So we took his little, toroid design and we made it better. And that's this. So,
very cool. How did he take your design? Did he watch your video or?
Yeah. He showed he showed one of our video clips in his video clip where he's talking about, these guys did it safe. Well, we don't want to do it safe here. So.
Oh.
Never does.
Yeah, we used 100 picofarad capacitors because those are incapable of delivering a high enough current for sustained damage. So basically, you get this one that initial discharge. The body is designed to really handle an initial static discharge and just one pulse, but it can handle multiple. So the multiplier stage will build up to a very high potential, but then it can't continue to deliver that kind of current in a short situation, which is
Yeah.
why it's nice with that 100 picofarads. So he used, I think, 1,000 picofarads or something like that. And that will deliver a deadly amount of current continuously. So
Yeah.
we chose not to use that in our design.
Yeah, that's a nanofarad. Yeah, it's a lot more than a pico. Microamps.
Right, exactly. It acts electrostatically, anyways, is the idea. It's as close as you're going to get basically to an electrostatic system. By the way, Fun Fly Stick, the corporation, or the company that makes Fun Fly Stick, anyways, it's a Van de Graaff generator, uses a little rubber band that runs inside of a tube, a cardboard tube. Well, they emailed me on my Facebook page for joining the technicians back when I was running that channel before Exotic Propulsion, and they tried to tell me that I had better cease and desist because my device was stepping on their patents, and I'm like, well, I'm not selling it first off, so
Yeah.
please go suck a bag of D. And
Yeah.
I said, secondly, this exists in the patent records since 1935, which are
Van de Graaff's
expired,
fucking
and
old.
you guys can also go, bite the big one, because I have no intention of either selling this, nor if I sold it, have any intention of giving you anything from this, so leave me alone.
Yeah.
I have patents that go back and prove this stuff was publicly released and is well within the records. They cannot say that just because you stick a battery on a voltage multiplier that you are therefore subject to regulation of their patent because they created a kid's toy. But yeah, they actually sent me three different threatening letters to not tell people how to build these things and not to dare sell them. And so I just told them to suck a bag of deep, like I said. So.
I mean, it's kind of a compliment that a big company looks to you and as competition when they have all the smart engineers they're paying, and you're stepping on their toes. I mean, it's kind of a backhanded compliment. But
well,
yeah,
it shows you how different the ideas of profit motivated versus idea motivated.
Yeah.
So
That's a good
corporations, I
point.
mean, like that. You've got Sharper Image, for example. Think about it. Sharper Image created the ionic breeze. They purchased rights to patents that had been expired in order to sustain them, and they had some kind of special way that they managed to grab T.T. Brown's patents. If you take a look at the references on Sharper Image's Ionic Breeze, they are actually using some of the circuits and designs from T.T. Brown's motion converter or kinetic systems. And I think that's pretty fantastic. Now, not a lot of those are sold these days, and the same technology basically hasn't changed. I did get my hands on an Ionic Breeze once and take a look at their driver circuit. It's fantastic. They're pulsing the output DC in a very similar way to the video that I showed you guys, and they're getting a much higher efficiency for it. So
interesting.
Yeah, even old stuff like the anti-grav guys, Thomas Townsend Brown, have been still relevant in today's market.
Interesting. Well, thanks for sharing. Well, that's great. Are we supposed to hear from Gerald and his components? And
I can't find him.
Oh,
I've been looking for him for the last 5 minutes, and I can't find him. I sent him emails and messages, and I don't know where he went.
He dropped off.
Well, I'm gonna jump off because I've got to prep dinner. So
thank you so much.
Have a good night. Thank you for coming on. I appreciate it.
Good stuff.
Yeah, it's kind of crazy. He just kind of disappeared there and didn't leave a message to me or nothing. So I don't know what's going on. Hopefully he'll pop back on soon. I'll leave him another message. I think I'm just going to load up his box. It's kind of crazy.
Good. Yeah. So what's the latest on your Graviflyer work, or have you been just posting those videos?
Well, I've been working on it, but I haven't posted a lot because Oh, I don't want to say this. I got it to do stuff, but I'm not ready to share that stuff yet because it's on that borderline of getting it done.
Yeah.
And I'm just, kind of just a little bit more testing. About 30 days, I should be close.
Awesome. Awesome. And how about your rodent coils? Have you been the vortex coils? Have you been getting them to move magnets and
So I have magnets here. I just don't have a sphere magnet. I'm waiting for that to come in. My rodent coil's ready for my stereo hookup.
awesome.
I got to get a cheaper stereo because I don't want to blow the one that I have.
Yeah.
So, but I did set it up. I did wire it the other day. I found time to do it, which is just for me right now is just crazy.
Yeah, nice. Yeah.
So I got that going. So hopefully that spear magnet will be here soon. I'll go over and pick up a receiver for like $40, and then you know what I mean. I'm just gonna hit it and see where it goes, and then we'll put some more circuits into it. That Gerald had the circuit tonight, and that's kind of what he was going to present. So we're all looking forward to that. You know what I mean? And what he's got going on there. And then those cats, man, in the beginning, they just watched the program.
That's funny.
It's absolutely amazing. I love the kittens. I got 4 cats of my own. So
awesome. We're dog people, but I like cats. Cats are awesome. So do you need a certain output power wattage for the stereo, like 1,000 watt or 1,800 watts, something like that?
I think Ben had a 100 watts or something like that. And I think that's with both channels. He now has, I think, 100 watts per channel or 80 watts per channel.
Oh, wow.
And it works perfectly fine.
That sounds great. I picked up some 1,000 watt, 1,200 watt receivers at the thrift store.
Nice.
And they were the display case. So they had the stickers on it, never been used. Yeah. And I mean, they're 15, 20 years old, but in some respects, that's actually better. They have real components. It's not all double printed circuit boards. It actually has real components you can see. And so, yeah, I'm working on one of my many experiments, and one of them is ultra high power, ultra low frequency waves. Basically, it's building a fan in your window and using the outside of your house as your speaker. And then it pushes these ultra low sound waves through the house.
Okay.
Yeah, I picked up a bunch of really powerful amplifiers from the thrift store that I'm fixing, and they're going to be part of this experiment. So basically, you ever hear those cars and they're driving by and they're really low to the ground and they have that bass boom and you can hear them?
Yeah. You do that at your house?
I'm kind of doing that with with my house, but almost on the earthquake level. So that's I have such a list of experiments, but that's one of them. Another one is I'm working on levitation. And
you are.
Yeah, that one's going to be fascinating. It's right after the ZVS. I'm achieving levitation based on some of the principles that Merkaba is working on with his spinning sphere magnet, where he's basically blending the polarities of magnets and even maybe distorting the magnetic waves, because that sphere is spinning so fast that it's almost like blending the north and the south poles of the magnet. And so it's kind of based on that. But what he's doing is on another level. As he increases the speed through feedback of that sphere, I just feel like it's going to, I don't know, like the TARDIS, it's just going to disappear. I don't know. What are your thoughts?
Say that last bit again.
So when Merkaba, I'm sorry, I don't know how to say it. The sphere magnet that he has spinning at ultra high speeds, and he adds feedback with each toggle switch to increase the speed.
That's right. Like a little
You get-
push.
and faster and faster and faster. I keep waiting for it to either levitate or go into another time dimension. It just feels like anti-gravity or the slowing of time or the distortion of the time-space fabric of space-time. It just feels like it's doing all of these things, and I can't explain it, but I'm excited because he's working on new lubricants to get it to go even faster. He's using tungsten powder.
Yeah.
It's amazing.
I just worry about a system getting gummed up. Like he has problems with burning through on a
Yeah.
couple things. And then if you put too much stuff in there that you constantly have to put in there, it might burn it up. But
Yeah.
then it might smooth it out. I kind of up in the air on that.
Yeah. It's
I would-
not
I-
easy.
I'd like something that would fill in the grooves and then make a really solid state. Because he just needs it to either sit against something solid or have air in there enough or magnetic field enough that it'll stay
Mhm.
where it's supposed to. You know what I mean?
Yeah. When I was
So-
in the Navy, we had a gyroscope, and it was a tiny ball of beryllium, and it spun at 27,000 RPMs. And it was a magnetic bearing where magnetism pushed it up, so it was levitating, and then it was sped up by electromagnetism to that speed. So it was not touching any surfaces, 27,000 RPMs. And then as the ship was changing direction, that little ball would tell the course and everything. So it was a really fascinating. I shared that with Merkaba, and we had some interesting dialogue about that. It's very fascinating.
Yes. That whole thing is fascinating.
Isn't
Every
it?
time I talk to him about it, yeah. It's like so every morning I talk to you and I talk to him and I
Mhm.
talk to Joe as well. So and then we all have
Mhm.
different things going on, man. So I'm trying to figure out mine while you guys are figuring out yours.
Yeah.
Every time I get Merkaba, man, it's like he's done with his day usually, and I'll catch him in the morning, or vice versa, whatever it is, because he's got that difference in time.
Right.
So he had just got done casting something or just started, you know what I mean?
Yeah.
And it's always at the best time because he's always working on that specific part.
Nice.
So anyway, yeah, I just think some of his stuff, once he encloses it, like if he
Mhm.
encloses that whole thing, it's
Yeah.
going to start to bounce that frequency.
Hmm.
So when he starts hitting it, it's going to bounce and then hit it again and it'll bounce again. It's like
Yeah.
pushing kids on a merry-go-round with that thing.
Yeah, exactly. It
So,
it just when you hear that high pitch each time, and you're just, wow, is it
oh,
going to
yeah.
take off? Is it
That's
you know, like
increasing like
pure-
crazy.
Yeah, it's pure speed. Incredible. Yeah, I have 2-sphere neodymiums, and I'm interested to see with some coils that I've gotten ideas from Ben and from Gerald to see if I can get them spinning in the middle. And so, but I've been knee deep in the ZVS, and as you know, we vacationed for a bit of time. So yeah, I'm really married to the ZVS. I really been looking for a circuit like this that's so easy to get up and running, and it's so simple. And yeah,
That little capacitor seems like it adds so much to that circuit. And that diode that goes with it.
it does. It really holds that charge that's just enough to keep the diode flowing. Otherwise, the diode won't flow, and then you won't have the feedback to the MOSFETs, because the feedback tells the MOSFETs to turn on or turn off. And that's the trick. That's why I use that switch. They're on the DC input to the ZVS. Remember that switch?
Yeah,
You
I
turn
have
the
it on
power
mine.
supply on? Yeah, it's because it really needs a sharp voltage rush or sharp current rush in order to bias those diodes, those feedback diodes, to where you'll get a proper oscillation. And that little tiny capacitor just gets that little charge and holds that diode open just enough to keep it oscillating. And yeah, it's incredible. One of those ZVS circuit boards, I'm going to build all of them. It's from SciTube HD and Archangel.
Oh, I know Archangel.
Yeah, and I printed a bunch of they posted their Gerber files for free. I sent them to PCB JLC PCB way, and they charged me like $1.50 a board.
That's not bad.
No, it's not bad at all. And I ordered like 30 of them, and because I just want to do a whole bunch of different things with them. And one thing that's unique about their ZVS, and I'll present it in another if you want, I'll share it with the group. But it has two power inputs. It has a 12-volt power input, and then it has the 0 to 55-volt input. If you connect just the 12 volts, that biases those diodes, and it immediately just perfectly oscillates. The problem is it doesn't have really a lot of power. It just kind of works almost like a signal generator, where it just outputs a little sine wave. And then that's when they then add the other power, and that can power the Tesla coil. Okay. The only thing about, so it's interesting because you have to have two switches. First, you get it just oscillating, then boom, you add the power. The one with the capacitor and the added resistor, that's just a dream ZVS, to be honest. It just purrs like a kitten, always works. And if, you've been in this long enough to know that to have a circuit always works is rare.
Yeah, because I blow a lot of them up.
I can tell you 100 different ways of how to blow up a circuit.
Hey, real quick before we go any further, I just want to tell everybody, Gerald sent me a message. It looks like one of his little kittens spilled his wife's drink on the router, so it blew up his ability to be online.
Oh no!
So he sent me a message from his wife's phone to the email. So he's gonna get a new router tomorrow, but it knocked him out of commission for tonight.
Oh, bummer.
Yeah, it sucks because he's supposed to present and he didn't, but we'll get him again. So that sucks.
I can't, from my view, read the chats. Is there a way to read it? Or
you know what? Somebody asked, did you finish all of the boards that you bought? All the ones from around everywhere? You said you tried to collect them. Did you build them? No, only the one that had the components on I built. So the smaller boards, one of them is a 2-power board for Tesla coils. This is one of the small boards. The other small board is used by an engineer who designed it for wireless power. So it's another invention I'm working on. Another design is I'm going to use that one for wireless power. So every 3 feet, you'll have we're all interested in that one. Yeah, it's fascinating. And then the one I'm using currently was for a 1.4 kilovolt induction heater. So a high voltage induction heater. The biggest one is just a bigger copy of the one I'm using. So they're both designed similar. And that's a 3 kilovolt induction heater. And so I just thought I wanted to start small, and I just actually started in the middle. I didn't start the smallest. So yeah, it's really cool. You just ask them for their Gerber files, they'll point them to you, and you just upload them, and then you pay. It's really simple. Nice. They come back with corrections, or they just do what you want?
They'll do what you want. It's these are just smarter people than me that are designing them that work, because they present them on their YouTube channel, so they obviously work.
Right.
Um,
I was
but
talking
yeah.
about the PCB way.
Like,
Do they
do
double
they
check
fix-
your work, or they just print what you send them?
that'll cost more to double check your work.
Okay.
Yeah, they have a guy. I think it's like $50 per half an hour, something like that. And he's a real engineer. And he'll kick back your stuff and say, "Hey, change that." Yeah, it's not cheap, but yeah, they have it.
Okay. I'm just curious.
Designing PC boards is just a whole nother talent, a whole nother skill set. It's enough for me to build a schematic and then build it to work, but to make it on a circuit board with a good layout. Also, too, the big one, the big board, and the medium board that I'm using, the guy that designed it says you should get a big ball of solder and load up the traces on the bottom. So you have these lines on the schematic, on the PC board on the bottom, silver lines connecting the capacitors. He says triple the thickness with solder, and then you'll reach 50 amps. That's on the big one.
Nice.
Yeah, super nice. One of the problems I'm having is I'm blowing my circuit breaker in my house because I only have 15 and 20 amps.
Oh.
Yeah, so I have to use my buck boost power supply. It gives me the 42 amps. I have to look at it. And then I have another one that has 18 amps. But I can't use my Variac.
Huh.
Pop my breaker every time.
Well, that's not good. Not if you're looking to push 1,000,000 volts.
I know. I know. I need to be thinking more efficient, like Jeremiah, right?
Well, I don't know. I like the 1,000,000 volts. You know what I mean?
I do too.
So you're going to have to find a way to get around that.
I will. I will do it. I don't know when. But I mean, if you think about just even the coil that I shared, that's about 100,000 volts. So I'm getting, the sphere was giving me like 200,000 volts, 150, 200,000 volts. So I'm in the ballpark, but the thing is, once you get up to 100,000 volts, every 10,000 volts is harder. If you get up to 500,000 volts, every 500 volts is harder. So it's not this linear thing where you just keep adding. No, it gets harder and harder as you move up. So yeah, that's the challenge. I'll get there. I believe I can.
Yeah, you're gonna have to design your own parts at some point because they probably don't make them, or you're gonna have giant room size diodes and capacitors. They'll be your whole basement when you go to start.
Have diodes the size of my head.
Yeah. Like, I can see it now. Sean goes, "Oh, that's not a room anymore. That's just for my Tesla coil. Don't worry about that.
Yeah, that's right.
Just don't touch the door."
The whole room is my experiment. That's
Yeah.
it. You open the door, you're inside my ZVS circuit. My wife would really like that.
Oh man. You replace where the antenna for the house, the old school antenna, you just put a Tesla coil on the top. Yeah, don't worry about that one.
Oh, that's so good.
That one's just for my wireless power for my lawnmower.
Right. Exactly. Exactly. Yeah, I think you'll like the wireless power designs that I'm going to do next. I think you'll like it.
Well, I think that's kind of cool compared to what we're doing. I mean, Gerald was talking about it, putting the wire to the rooftop, the antenna and stuff like that.
Yeah.
It's just kind of taking it to another level. You know what I mean?
Yeah, it's fascinating because if you get this little ZVS fired up, it's going to be able to provide radiant energy to about 3 feet. And then if you wind up, it's sort of a broad, a large diameter coil, and you wind it with the same capacitance and inductance as the ZVS. And what the ZVS will do is it'll see that and it'll oscillate it at resonant frequency again. So you get this big jump again. And so you get these big jumps in between these coils. And I'm seeing the comments. Oh, that's awesome.
Oh, sorry.
No, I haven't seen them the whole time.
I try to keep them off during the presentation so I don't throw off the presenter.
I see. I see.
Yeah,
Yeah.
and then I'll bring them up. Hey, I got a question for you. You said once you hook in that new ZVS, it'll take any Tesla coil and find the resonance frequency. So
Hmm.
if we're out of our zone that we were working in the 300 kilohertz range,
Yeah.
now you can go to any one you want.
Yeah. So there's three things that you need for the oscillator to calculate what the frequency is going to be. You need the capacitance. You need two of the three. Let's say you input inductance, and let's say 300 kilohertz is what you want for resonance. If you put those two into the calculator, it'll tell you what size capacitor to put in. So you can do it that way. Or you can say, I want to put in this coil, I want this coil, and I want this capacitor. Then it will tell you what the resonant frequency is. Now, I will say that the ZVS doesn't like ultra low or ultra high frequencies. It's not as low in my experience. Jeremiah knows a lot more than I do, but in my experience, ZVS handles 100,000 kilohertz or higher very easily. I've seen it up to running well at about 500 kilohertz. So it does have its limits. What was fascinating was I was able to get it to oscillate at megahertz, and I haven't figured all that out yet. But I don't know if that answers your question.
Yeah. One thing I did notice, so just so you know, when I put my gravity flyer and connect it,
Mm-hmm.
I'm in the megahertz range. And
Yeah.
it'll start testing out. Remember, we were only getting like I want to say it was like between 250 on the top, unless you add a bunch more winding, and then it was like 400 and something on the bottom, right?
Yeah.
Maybe get to 5. Well, when I put the wire down there, now it goes to 17 megahertz. Okay, on the bottom coil, bottom of that number 1 coil.
Mm-hmm.
So you see the difference in it?
Yeah.
So it changed the entire Tesla coil on my frequency range.
Yeah. And this is Slayer.
No, this is the same ZVS.
Okay.
So by adding that extra, it's like adding a bunch more wire or adding a second coil inside of the coil. So I'm pulling out the cold energy from it, like a cold energy pull circuit. Okay.
Mm-hmm.
When I
Okay.
do that, but it's adding, like it acts like it's adding more wire to the actual number 2 coil. So you get both effects. That's why it's confusing. You're getting 2 different effects out of it. You're not just getting one.
Now, are you describing the frequencies when your what is it? Your discharge wire is either out of the second coil 2 or it's down the throat of coil 2, and you're saying that it's giving you 2 different reactions?
Yes.
Okay, so how are you measuring those reactions? Are you using your oscope?
So they come right up on the oscope.
Okay, and you're using the oscope probe as like a little antenna?
Yeah.
You're not connecting it directly?
Not directly connected.
Okay. And so what's the frequency when it's not down the throat, roughly?
Let's see. It doesn't oscillate when it's not down the throat. Okay.
Oh, interesting.
So, like I said, it's set up to go 600. Is that right? I think it's 710 kilohertz is where it's at. We know that our ZVS only oscillated up to 500, right?
Yeah, and it starts chugging. It'll do 700, but it won't be good.
So you're not getting any power out of it. You're just frying wires.
Right.
So when I put the wire down the throat, it brings my resonance frequency back down to 275. Okay. Now I'm within my range. Now I can set it properly and get it to resonate properly. So what that does is it changes my feedback now. Now my feedback, if I put it in, goes in the megahertz. I can get up to 25 megahertz on a feedback.
So when you put the wire down the throat, the frequency goes from 700 kilohertz to about 200 and something kilohertz. So when you're putting it down the throat, that means you're increasing the inductance of the coil, because when inductance goes up, your resonant frequency goes down. So you're like you said, you're sort of adding more coil to it when you put it down the throat. So that makes sense that your inductance goes up, your frequency goes down. Now you're experiencing these megahertz on the O-scope.
Yeah.
And those it looks like resonant ringing is what it looks like that I've seen that you shared.
Yeah.
And when did that resonant ringing start? Is it only on the ZVS Tesla or?
It's only on the ZVS Tesla coil. When my Slayer exciter was connected, it wasn't doing that.
And the Slayer exciter, is the coil 1 and coil 2 identical to the ZVS or close?
They could be the same thing. Okay.
Yeah.
You could just switch out the circuits. The one thing I will say is the ZVS is grounded.
Okay.
The Slayer exciter is not grounded.
Right.
And because my actual gravity flyer is on the ground, I'm double grounded.
Oh.
So it pulls a whole nother thing out of it. That's why it amplifies in the amount of power going in.
Yeah.
It's that double grounding. It's making a connection through the ground and giving me all that power.
Yeah. And you said you're going to be doing some experimentation over these next 30 days to get to a point to where you're going to share the next level.
Where it's consistently doing things. Yeah. That's
Yeah.
it. That's all I want. So if it stands up on one leg, it's got to do it consistently every time. You know what I mean? That's all I want.
Yeah.
I don't want to have a situation where I get on a live and I go to hit the button and it does nothing. So
you want consistency. That's huge. That's kind of the earmark of a functioning circuit is, you can turn it on and it's mostly going to go on most of the time.
Yeah, because what it's saying is I busted the weight barrier.
Okay.
That's what I'm telling you. I busted the weight barrier. Now I just got to do it consistently. So when they say it's 3 pounds of lift, 3 pounds you have to lift.
Yeah.
Trust me, I get the 3 pounds off the ground. It's just, can I do it consistently? Because sometimes it's an EMP. Sometimes it lifts. Sometimes, you know what I mean? It falls over. It has to start doing it consistently, or else I can't put it in my garage to show anyone.
Yeah.
Because I can't bring my cameras that are attached to my computer out there.
Yeah.
I could take a crappy, grainy photo with my bad camera.
Oh.
And nobody's going to want that. And then I can't get zoom enough on my cell phone in order to get that. I guess I'm lacking in the correct stuff to do the thing I want to do. So I have to wait until it gets consistent enough so I don't blow up everything in my garage.
Yeah, that's interesting. And so when you say that you can't get the zoom on your camera, is that because it creates such a large electrostatic field or electromagnetic field?
So when it's far back on zoom, my camera's so bad, I'll just put it this way. It looks like Alexi's work.
Oh, that's interesting.
So it's all grainy and nasty. And I don't think it has anything to do with the field. It just has to do with a bad camera, old, not good.
Okay.
And then my cell phone can't zoom in enough to give a clear picture. It looks like grainy cell phone footage is what it looks like.
And you can't get closer because it'll start jamming things up.
That's right. There's too much power. I don't think I can get within like 3 feet of it without it being dead, where normally I can get right up on it.
Yeah.
So it zaps you pretty quick. So
yeah.
But that's the thing about the Tesla coil we're working on, because that's what we did, and that's how I modified it based on what my Slayer exciter was doing before. That's how I found it. So as soon as I plugged it into ground, that's why I keep telling people it's getting 3 rings. And I always say at the magnet, it could very well just be the grounding that's doing it.
Yeah,
So
right.
I don't, it's hard to say entirely because you see it on your scope, you know it's there. You know there's only so many components to give it to you.
Right.
And I'm not getting the ring out of my my flyback circuit. It's not coming out of there at all. I've tested it individually and ruled that one out.
Right.
So yeah, it's kind of strange.
Yeah.
So he must have that thing figured out where he double grounded and did everything the way I'm doing to get the result he's getting. But he must have taken it a step further to understand something more.
Right. Right.
So, but he even has trouble getting it up himself.
Right. I've seen the clips you shared. Yeah. It's we're on the edge of discovery and invention, and it's new territory. And so we kind of don't understand a lot of what we're moving into. And yeah, there's no words or mathematics or anything that are laid down as a foundation because it's all new.
Yeah, there's no law in physics for this. And that's why I wanted to look into the rodent coil and Gerald's coil and things like that.
Yeah.
Because they're tying into exactly what I'm doing. Okay. The way it's building its field, the way it's taking in the energy, the way it's using the energy, all of it. That's why I had to do it. I had to stop what I was doing, go back to what they were doing, and see if they have an answer to help me even this thing out. You know what I mean?
Yeah, no, I exactly know what you mean. It's sort of learning other free energy methods, if you will, or discoveries to help you better understand your free energy thrust or propulsion. I don't even know what to call it. Anti-gravity.
Well, it would have been so much easier to take Gerald's coil, put it right in the center, and then take a top and bottom plate and create a capacitor, and then pulse that capacitor. Man, I would have got everything I needed. That would have been simple. That's not the way he built it. So I just stayed with the way it is. I have another one that's kind of like Gerald's, but Gerald's got a secret, whole recipe to his coil that I don't have.
Secret sauce.
We all have our secret sauce. Mine's just saucier than more other people's.
There you go.
Yeah, exactly. Yeah, interesting.
Yeah. It's kind of crazy when you start looking at it, though, and what you're doing, and then all the different tests you have to go through to start to see something.
Right.
Man, you know how I spent like 6 months straight just trying to figure out exactly what each part was and what it did, what the reading on the oscilloscope was versus what I was putting into it. So it's been one hard road to figure this thing out. I'll tell you that. It wasn't easy.
Yeah. I can tell. People can tell you've really mastered the parts and how to put it together. You're very, very close to how it works and the information. And it's, you can tell when somebody's just presenting something that they are reading slides or glazing over it. But no, there's a depth to what you're into, and you're explaining and you're showing us that you have spent the hours on each part of it, each component.
I never write anything down, by the way, not to go on video with. It's all out of my head. I know it inside and out. I don't ever read a script.
You're you rely on intuition, which is the highest level of expertise.
Well, that I've done the test so many times that I know it front and back what I'm talking about.
You can hear, or you can sense, you can smell, like your senses are all being affected when you get to that level of understanding what you're building. Like you can just feel it in your skin, in your bones. I have that when I'm working with high voltage. I just sense the humidity's right, everything's right.
I could tell when you start building your coils and they look like some insane shape, but they seem to resonate all the time.
Yeah.
Have you
I
seen those, Mike?
What's that?
Have you
His
seen his
coils?
Tesla coils?
Oh yeah, I've seen a couple of them. Yeah.
have you seen the sphere?
The sphere one, yes, that's really cool.
Thank you.
I still think you're pulling it in, not pushing it out.
You're the one that saw those tendrils. I look for those tendrils now. They're these sort of spiral streamers. It's
Yeah.
fascinating. Spiral streamers. You know, I don't get them from my other shapes of coil, only the sphere.
Yeah.
And I can't wait to see what the toroid's going to do, because the sphere has the ability to place equal charge around it because it's a sphere, and charge is repels each other. So if you fill with electrons, they all space out. But a toroid actually doesn't allow electromagnetic waves leave, because it's in the shape of the electromagnetic waves that are being created by the electricity. So if you're not losing any electromagnetism, what is that going to do with the Tesla coil sparks? I have no idea. I'm printing the forms tonight, and I will set the epoxy tomorrow, and then I'll pull it out and figure it out. My big problem is the ground line and the plasma discharge are only like a millimeter away. Because if you look at it, it's a donut, right?
Yeah.
It starts and then ends real close to each other, because you go around the whole ring of the donut. And yeah, I got to figure that out. And I'm usually like that. I just want to just build it. I don't want to overthink it. You know, the paralysis of analysis. I'll epoxy it and worry about it when it's when it's up out of the epoxy. I mean, I'll do a little thinking. I mean,
You're starting to go with my method. Fry it and find out. You're going to fry something with that. Go around the circle, come back to the same spot.
what's funny is I took one of the halves of the donuts. You know, it's like a C shape. And I thought, you know what? I'm going to run some voltage through it on the ZVS just to kind of use it as a video clip for a presentation. But it didn't have epoxy. And I saw a plasma discharge come right out of the center of it, burning a black Mandelbrot, or what do they call it? Not a Mandelbrot, fractals. It burned a fractal black carbon spot. And I thought, oh no, I'm going to set it on fire before I even get an epoxy. So that was dumb.
Here's a little good saying that I heard about doing something you don't like to do, like say like winding a coil. You know, a lot of people just stress out when they wind a coil. So it's wind a coil, even though you hate it, but do it like you love it, and you'll be successful.
Interesting. It's just a change of attitude almost. Just
Right.
psychosomatics. Psychosomatics are a real thing. People try to say what's all in your head, and so it's not real, but no. It's all in your head means it's real.
You know, I've wound coils till, you know, my hands like completely cramp up and get like really, really sore to the point where I have to tape it off where I was and just take a break for a minute, but go back to it again and finish it, you know?
Yeah, I get that.
The coiling is probably my second favorite, being lighting up, sending sparks across the room is my favorite. But coiling, it's just methodic. You can sort of watch a YouTube video and
it's like knitting, right?
It's exactly like knitting. Exactly. I always look at it that way. Plus, the shape side wire aren't really the same old, so that's unique. That makes it kind of fun, I guess.
Yeah. Yeah, but I was smart. I actually built myself a coil maker. I took one of those motors you buy on Amazon. They're like made for electric bikes and stuff like that. I think they're like $40. So I took that and I got a threaded rod and I 3D printed all the rigging and, you know, bearing holders and everything. And I made a really nice little winder. And let me tell you, I can make a really, really large coil in a short period of time now because I
Nice.
got I got a little foot pedal control and a potentiometer so I can
Nice.
control my RPM. And if I want to stop it, I just tap it with my foot and it'll stop. If I have to restart or whatever, regauge or whatever, and carry
Yeah.
on. And man, did it save me hours and hours of winding.
Well,
Yeah.
see, I see one of those for a Tesla coil, and then they use the epoxy on the self-leveling method where they leave it overnight and it's still turning all
Yeah.
night,
Mhm.
and then it
Right.
levels it out for you. That's what I need.
Yeah.
Mm. Well, a lot of guys use like lathes, right? Some people have, homemade or like lathes that in their house or in their garage, right? Small ones, and you can buy them at Canadian Tire, or I think you buy them on Amazon too. Small little lathes, and
Yeah, 500-600 bucks.
Yeah. Hobby
yeah,
lathe. Hobby
yeah,
lathe.
hobby lathes, yeah, and just rig it, and you can make coils on the little lathe very easy.
I think I'll make my own coil maker.
Well,
I'll do
that's
it
what I
for
did.
under $100.
Exactly, and that's what I did. Right, I wanted to make one that was cheap and had full control with a foot pedal and a potentiometer, so I could
Very
control it.
cool.
And I also got a timer, or sorry, a counter. So for every
Oh,
revolution,
nice.
Oh, you count the turns on it, yeah.
yeah, I got the analog thing with the proximity sensor. So every time it hits it, it starts counting. It's digital, and I
Wow.
can
Nice.
reset it. And, yeah, and all the stuff I bought on Amazon, and just 3D printed all the rigging and all the um, supports for the bearings and the motor seat, everything. So it turned out really, really good.
Nice.
Yeah. Sounds awesome.
Yeah, it runs on a 12-volt battery, and that's it.
And so have you wound a lot of Tesla coils, or what kind of coils are you winding?
Well, for my reactance coils for my pulse motors. So
Okay.
the Renegade, each coil is over 2 pounds each. So I got 4 coils. So
Wow.
yeah,
What's the wire gauge?
those ones I use 24 gauge,
24.
Wow. 2 pounds.
2 pounds each, and I got 4 of them.
What?
Dude, that's
And
that's a lot of money right there just for those 12.
it's a lot of
That's
copper.
$200 worth of copper wire.
Yeah. Yeah, it is.
Was that pre-COVID? Because I think copper's like tripled.
Yeah. This one here, I got it. Yeah, it was about a year and a half before COVID hit. Yeah.
Yeah, you got it, because everything's up. So have you presented on those 2-pounder coil setup?
Didn't you do it a
But
week ago or so?
not the Renegade device. I have a smaller version, but the big Renegade, I have videos on my channel of that specific motor. Yeah, you showed it, Gerald, on your cast. The
Yeah,
one
he has
with
a
the
nice
boom
big
lights.
one in the case, is what we
Yeah,
saw.
yeah, it's
And
a
he's got
server
a
case.
I think I've seen it. Okay.
yeah.
It's in like a
that
clear
one.
acrylic box.
No, that's a server case. That's in a server case. It's the whole rig
Oh,
is 100. The whole thing with the batteries and everything is 100 pounds, 120 pounds, something like that.
wow.
Yeah, it's heavy as hell.
Yeah. Fascinating.
I actually had to build a small dolly for it because it was just too heavy to lug around. So I made a dolly for it, a flatbed
Makes
dolly.
sense.
I'll
Makes
show it
sense.
real quick. This is his show you real quick. Here's his Renegade.
That's the small one. Yeah, that's the small one. The big one's the other one you showed there a week ago.
All right. So you have a toroid power transformer. You have a giant power cap over to the right.
So my device, what I use is a disruptive discharge switch to create the reactance in the coil, and that
Okay.
reactance is dumped into 2 piezo transducers in series.
Mm-hmm.
Okay, so what happens is I get the recoil from that. It goes back into the coil, it resonates, and then comes out. So I'm amplifying the reactance that's created in the coil.
Hmm.
So because of that reactance, what happens is, because I'm using a spark gap switch, automotive relay switch, and I've overclocked it so it goes a lot faster.
Hmm.
When you get the physical release in the switch, the current off the battery goes to zero. So on that motor you're looking at, it pulses 4 times per revolution. So because of that, the amount of current draw of the batteries is in the microwatts. So I could
Wow.
run that motor on dead batteries. That's how effective it is. And I can
Super
run
efficient.
crazy efficiency in it. Like
Yeah.
most of my amp meters won't go that low.
Yeah.
So it's in the microwatts.
Nanoamps.
Yeah, nanoamps. So because of that, what
Wow.
happens is, the batteries, especially lead acid, they have a pretty cool attribute that they can recover. Because I'm pulling such a small current
Hmm.
off those batteries, the ionic charge never really leaves the battery. So
Mm.
I'm just robbing the battery of its voltage potential, not current potential.
Mm.
That would explain it.
Is that sort of self-healing the battery?
Yeah, well, I've been using, like, on that device that you're looking at now, I'm using the small 9-volt batteries.
Hmm.
I've been using the same batteries for over 6 months, and they still
Mm.
work.
Are these rechargeable 9 volts?
Nope, they're just a regular zinc oxide battery. Those small little 9-volt batteries. I've got
And
4 or 5 of those.
and so you're
But for
drawing almost no amps,
right,
and so it holds a charge indefinitely.
yeah, because like as soon as I shut the motor off, come back the next day, the batteries have regained power.
Wow,
They bounce back.
that's fascinating.
So like
This
the
is the
big
big
Renegade,
machine.
Are those the
that
2
one there,
powders?
yeah, I got 4 of those in that motor.
Wow. Are those neodymiums in that spinning disc?
Yeah. I believe I think it's 8 or 10. 8, I think. Yeah, 8 neodymiums.
It's a nice build.
Uh,
Really nice
yeah,
build.
the wheel itself is 12 inches in diameter, just to kind of give you a perspective.
Hey, Mike,
Okay.
I got a question for you on there. Your trigger coil, is that the
Yeah.
one at a different angle?
No, actually, that's a pickup. The one that's driving the whole thing is the back right side.
Hmm.
Yeah. So the 2 in front of you and the one on the back left, those are all pickups.
So why is the one different? What was the reason?
That is a good question. That is actually a very good question. For some reason, at that angle, I'm picking up more current. When I change the angle of attack relative to the spinning magnet, I actually increase the current by turning it almost 90, well, not quite 90, I would say 70 degrees offset of the center. I don't know why. I have never been able to explain why, but for some reason, when I turn it to that angle, the
Hmm.
current increases.
Wow,
I'm
that's
still trying to,
interesting.
I think it's the way the flux is being pushed away
Yeah.
as it's coming around.
Yeah. Now that's the pickup coil is at the angle. The driving
Right.
coils are straight, right?
Straight. Yep. The other coils I put, the other pickup coils, the one on the left side at the front and left side at the back, they're
Mhm.
almost dead on center. But the last coil that's turned, that's the last one of the coils that's in series.
Mm.
Those three coils are hooked up in series. So I'm not getting full voltage out of the one that's turned that way, but I'm getting more current. So because I've generated current, I'm creating more current for the entire series of the 3 coils.
Hey, Mike, you got a question for you from the chat.
Yeah.
So how can I do that to scale the cell to my car battery?
Say that again.
So, Mike, how could I do that to scale the one in my car battery? I think he's talking about
like the
go ahead.
Bedini circuit.
Yeah.
Making
more or
it
less.
bigger.
Well, see, I'm using this one here. I got 4 motorcycle batteries running it. It's not full, full, but mass is everything in this motor because it runs pretty much off the Newman principle. So the bigger the battery it is, the less significant that draw from that battery is. So the batteries don't even notice the current being pulled from it because it's so little.
Wow.
So I got 4 motorcycle batteries hooked up in series. So it's about 48 to 50 volts, give or take. Don't
Okay.
use 12 volts. Stay away from 12 volts. Don't be a wussy. Go up to 50 volts. Don't be afraid. Even Paul Babcock says the same thing. Don't be a wussy. Go up to 50 volts, and you'll get way better results.
Wow, we're not afraid to use power around here. You were showing our eyes.
Yeah.
Talking to the right guys here.
There you go.
No fear of volts here.
Yeah. Hey, I got another question from Society of High Sciences. Makes the field or flux in the coils parabolic in geometry. Does that sound about right?
Yeah, I would say so. The drive coil runs on reactance. The pickup coils are I would say that's right. So this motor is still a work in progress. I kind of put it away for a while because I needed a bit of break. Sometimes you get into a bit of a rut, so you have to set it aside. So I've been concentrating more on the power cells, but I will go back to it. I have a few ideas that I can throw into it and see if it works, right? Sometimes you just have to.
Awesome build.
Well, it looks really nice.
Yeah, it's clean.
Yeah, the front case plate is like a really nice tinted glass. It looks so good when it's closed up. And I got the Renegade thing. I think I've got pictures of it in the community section on my YouTube channel.
Yeah, your PoE coil looked really nice too. The one you did like a Gerard Morin design and you made the blue in it. You got a thing with that blue lights look really good.
Oh, you're talking about that spark gap I have. Oh, let me tell you a little story about those things. A friend of mine, he can find pretty much anything I want. He's like, eBay, like 101 here. He found these spark gaps from an old guy. He lived in Southern California. He knew a guy that ran a surplus shop of old Navy stuff. It was a pretty large building, and they were gonna tear it down or something like that. They had to shut it down. So he told the old guy, "All right, go in, grab what you want, and run." Basically, free for all. So he found these spark gaps, original spark gaps from naval battleship a radar system.
Wow.
So when I got these things, he bought, I think 6 or 10 of them. I think I have. I think 6 of the small ones and I think 8 of the large ones. But anyways, it's still in the original box dated March of 1945.
Oh, wow.
Yeah, they're Navy, World War II Navy surplus. Still in the box, never been opened.
Was Canada in World War II? Just kidding. Just kidding.
Yeah. Oh, yeah. Yeah. But most of our naval surplus was out in Vancouver. Unfortunately, I'm in Toronto. but that's where John Hutchison was able to get all the stuff that he could because he lived on the West Coast, right? So, oh, you're looking at that one, the Gerard Morin.
Yeah, where's the other one that shows the blue box? I can't find it on
Yeah.
your site.
It should be there. It should be one of the later videos. Click on video.
I did.
Oh, you know what? I put those ones in the members.
Oh,
Yeah, I put that one there. Yeah, because the channel got monetized. Oh, I think it's right there. Is that it?
no, this is your big one we saw already.
Okay. It might be in my members.
Yeah, I think you moved it because I can't find it. I looked for it several times actually.
Yeah, I think it's in the members section now.
Good stuff. Thanks for sharing.
Yeah, I've got over 465 videos now, I think.
You've been doing this for a while. It's great.
Yep. Yeah. And my community section, I got a lot of great stuff in there. I got a lot of postings plus live shows. I got a huge archive of live shows now.
So,
Nathan, know what I've done is started to promote your show in the Facebook news groups, free energy news groups. So
Okay.
You should be getting some more traffic your way.
Oh, very nice. Thank you very much for that.
Yeah.
I have a question. Mike, if someone were to get started into the hobby that you've shared, where would you recommend they do?
It depends on what project you want to start. I would just start with say like a simple LC circuit. Learn the basics, right? Learn how to blow stuff up too, because you have to learn. Like, there's only one way to learn. Sometimes it blows up on you. So
Right.
You have to fail, right, in order to learn.
Fail forward.
Yeah. Just start with simple circuits. Jewel Thief, that's a good one to start with.
Yeah.
That'll give you the basics.
Yeah, that sounds interesting.
Does that pulse motor have a lot of circuitry?
That really is the most basic circuit ever.
Just the little meters that read, what was it reading? Amperage, voltage, RPMs?
Yeah, mainly just voltage and amperage.
And you just buy those on Amazon.
Yeah, that one there you can buy on Amazon. They can handle, I think, like 15 or 20 amps. Like when mine's running, like the big Renegade, the blue one there, when that's running, it doesn't even register the current coming off the battery. It's like 0.0001. It's like a 4 decimal place. So
it's incredible.
Like, so when it goes that low, I'm going, yeah, I'm on the right track. That's exactly what I want.
Right.
There you go.
Have you ever added load? Have you ever added load to these motors?
The second you add a direct load to that circuit, you kill the dipole. You have to leave that dipole open, so you have to harness power outside of that dipole. There's different ways of doing it. Like a lot of people say, oh, you have to loop it, you have to loop it. No, you can loop it very easy. You just have to break the symmetry of the power going out, put it through a full wave bridge, dump it into a cap, then put it through another full wave bridge, and it breaks the symmetry. And then you can actually, your back EMF coming off the coil can be rerouted back into the battery that drives it. But a lot of people don't understand you're creating negative energy. So if you start putting negative energy into a positively charged battery, eventually that battery is going to die because you got two different types of battery charges.
So do you have a setup that has a load for experiments?
I was more focusing on achieving almost zero current going in. That's the key. That's where you make your own. If it starts right at the very beginning. If you can master the beginning, getting power out of it is 10 times easier because you're putting your current draw so far into the minus
Mhm.
When you start extracting power, you got a bigger gap to play with.
Do you extract the power from the batteries while this setup is
Well,
charging?
Well, those 3 coils is how you pull the power off.
The
It's
pickup.
it's not. That's right. So I'm using the spinning mechanical motion of the wheel to
Mhm.
create that on off through those 3 coils to pick up power without killing the dipole. It cannot be connected to that circuit. It has to be separately independent from that circuit.
Interesting.
The key is to boost that up. So if I could sustain, say, like 5 or 10 volts steady, you could buy these little step up circuits that can take 5 or 10 volts and boost it up to 120 volts.
Yeah.
Very easy. That's where you get your over unity now. So you're drawing microwatts of power, but yet you're putting well over 100 volts AC pulsed, and you can run 120, a 40 or a 50-watt light bulb.
Wow.
So, right? So you're getting your over unity that way. And then
That's fascinating.
Tom Bearden, Bandini, they talked about, the only way you can do it is by not killing the dipole. It has to be a separate circuit. So the only way to collect that energy is those coils sitting outside harnessing the flux going with the neodymium spinning on the big wheel. That's where that separates the pickup circuit from the drive circuit. They cannot coexist together as one circuit. You would kill it. It kills the dipole.
That makes sense. So are you just sending the pickup coil power straight to the batteries right now, not to any type of load experiments?
No, you just send it to the whole idea is to have a set of batteries in theory that never wear out, but can charge up car batteries day in and day out constantly. There's always a flow of power. Because of a not direct connection, it's separate from the main drive circuit, and you're just using those 3 coils, pumping up that power, dumping that into deep cycle car batteries.
Yeah.
Knowing that the battery bank that you're using to power the system never wears out. Well, there's your over unity. It's not over unity maybe in straight numbers. You're gaining over unity versus time.
Interesting.
Nobody talks about the time factor, right?
Yeah.
So it's like the race between the rabbit and the turtle, right? The rabbit might get there faster, but he's going to be totally exhausted by the time he gets to the end of the race. But the turtle might take longer to get there, but guess what? He can keep going and going and going. That's exactly how this motor works.
Just a careful step-by-step processing.
It's creating a waterfall. It's like creating a waterfall. You start the waterfall, make it so it never stops.
It's a good analogy.
Right?
Makes sense.
And that's what the crystal power cell is. It's basically a waterfall inside the power cell.
Fascinating.
Different principle, but same concept, different principle.
Yeah, that's cool. That's one thing I always say. You got to have some kind of a break. You can't just pull from your motor that you're trying to get the energy from, because you'll kill it. You have to get a break in there, and then whether that's capacitor, battery, whatever, in order to get your power out.
Yeah. See, I'm using mechanical spinning that my dipole is creating with that wheel. So think of the wheel as the waterfall, or the wheel of the like the water wheel, right? And then just picture magnets now on that wheel, and if you put pickup coils beside it, it's not part of the circuit, it's separate from the circuit, but it is taking advantage of the mechanical motion that your dipole has created, or the waterfall. Right? There's no physical contact.
Have you noticed any drag on the center spinning disc when you try to extract more power from the pickup coils?
I dead shorted all 3 coils and it still chugs. It keeps going. It just keeps
Interesting.
going. Yep, it just keeps going.
Because they're
And
not
also,
part
too,
of the drive circuit.
That's right. It's not part of the circuit. It's completely separate from the dipole. There's no physical connection.
Yeah, that's interesting. But there's electromagnetic connection, but somehow
Right.
you're overcoming that. Even on a short
Right.
doesn't have resistance.
So most people say how you're defeating Lenz's law with your dipole. It has to do with that break and release. When you release, the pole flips. By the time the next magnet is spun around, it likes to
Mhm.
pull it in. And by the
Mm.
time it switches again, now it's repelling it. So the Lenz law is pretty much gone. I
Mm.
pretty much eliminated the Lenz law effect. And you can do it with the MOSFET to a point, but the spark gap switch that I use
Mhm.
completely defeats the Lenz law effect.
Yeah,
There's
I
no
mean,
drive.
laws are meant to be broken. So
Well, it's not. No, that law stays pretty firm.
yeah,
But you just have to come up with a way to circumvent it,
right.
and that's in the switching method.
Well, you do know the big power companies have a 3-spark gap system before it goes into line voltage.
Exactly.
They gap it 3 times, 3 spark gaps, and then it thins it out to what they want to send to their line voltage.
Yep.
Hmm.
They definitely have a reason why they do that, and it
That's
doesn't
right.
surprise me. It's a spark gap.
Hmm.
Because I believe, and I think, well, Tesla made it pretty well known that the radiant energy enters the system through the spark gap.
Angela, hurry up.
Yeah,
Right.
it's like it pulls it in as soon as it's like an explosion, and then it sucks it in.
Yeah, it connects that fourth dimension to this dimension and allows that radiant energy just to funnel itself right into the circuit.
Yeah. Have you ever seen the? Go ahead.
Like Tesla, he pretty much invented the rotary spark gap. I think today, if he was alive, he'd still be using the spark gap switch. I really believe he would. Even back in those days, they didn't have MOSFETs and SSRs and all these other circuits. I think he would still use the spark gap. I really believe he would.
Yeah, pretty amazing.
Well, there's all the critics out there, all the regular electronics guys. Oh, it's dirty power. It's inconsistent. It's parasitic. All this stuff.
Hmm.
Well, don't you think Tesla would have known this?
Yeah, Tesla was on a whole nother level. I mean, there's hardly any people as smart as him in history.
No.
Yeah.
Only once every few hundred years, maybe.
Yeah, he gave us AC, he gave us radio, he gave us the things that pull us out of the dark ages.
He gave us that Tesla coil, which is probably one of the most important things he did. Tell you that right now.
It's
and
incredible.
most people don't get it. They don't get what it is. They just think it's a thing that
No.
throws sparks in the air.
Yeah.
Can I share my Tesla coil real quick?
Yeah,
Sure.
absolutely.
This was the new coil that I wound, and this was my first test with the new ZVS. And you'll notice that the streamers aren't bigger, but look at how thick they are.
Yeah.
That's
What
efficiency.
what frequency are you running at? 40 kilocycles or?
I'm trying to think now. I can go look at it real quick. It's like 184 kilohertz.
Oh, okay, so that's pretty high.
But see how thick it is? It has those tendrils, but not like the sphere. But I just ran that just before we had this presentation time. I was running this quick, put it together, don't measure anything, just light it up, and that's kind of the coolness about the ZBS is
I was lucky that I was able to see an original Tesla coil made by Tesla himself.
wow.
I went to the Observatory of California up on the mountain there where the Hollywood sign is.
Hmm.
And I just caught maybe the last 2 minutes of the demo. I was so mad I missed it. But, it was, well, they put in a Faraday cage for starters. So
Yeah.
this thing was shooting out 6-foot lightning bolts.
Wow.
Nice.
Oh yeah. We're talking, the hair on the back of your neck standing up.
Very cool.
Very loud. Very, very loud. And the amount of ozone, holy man, the ozone in the air was just so powerful.
That's another thing. The coil I just lit off, no ozone. I couldn't smell any ozone. It's such a unique.
If you're
Mhm.
running at extreme high frequency, like over 100 kilocycles, I believe
Mhm.
your ozone attachment or transition of that ozone gas being produced decreases. When you're say in the 40 to 70 kilocycle, you get a lot more ozone.
Oh, that makes sense. I've noticed that. That makes sense because I'll have high frequency discharges like that, and I don't have ozone, but I'll have these lower frequency, less powered objects, and it smells up the whole room.
Yeah.
Yeah,
That
like my
makes
spark
sense.
gaps. Yeah, see the spark gaps, the one I have the vacuum tube ones from World War II. If I get
Mhm.
that thing pulsing, I actually create a small little EVO inside the tube. It actually
Mhm.
looks like it looks like a little planet forming in the middle of the tube. But man,
Wow.
the amount of ozone that it tracks was actually, I was very impressed. It created so much ozone in the room, and it was in the vacuum tube. It
Wow.
was
You can
still,
smell
yeah,
it too. You can smell it right away.
yes, oh yeah. Within a couple of minutes, you can smell it.
Yeah. I'll usually have windows like a cross breeze, or I
Yeah,
know I'm not all going to be locked up when I'm doing my high voltage experiments. It's not safe.
Yeah.
yeah. For several hours, that's not good for your lungs, but a little bit of ozone's okay. It's just very moderate, right?
Yeah, it kills germs in small
Yeah,
quantities. It kills
I
germs.
I ionize the air, destroys any dust particles that are toxic and stuff like that. If you got like a really dusty house, that helps get rid of the dust in the house as well. That's why back in the old days they used to make, my grandfather, he had this box. It was like a fan, but it had this little pin sticking out the front grill. So I was probably about 6, 7 years old, and he'd have it
Mhm.
running, and I go, Grandpa, what's that smell? And he goes, oh, that's ozone. It's an ionizer. So I go, what's that pin? And when I put my finger up to the pin, I got a little electric shock out of it. I'm like, oh, like this, right? And he goes, yeah, that's where it's making the ionization. That's the pin where the electricity comes out. I'm like, that's so cool. So that was 6 years old. That's when I had my first experience with kind of a ozone thing. It was my
Nice.
grandfather, right?
Well, it was back in the 1950s when you could do stuff like that.
Yeah, well, this was early, late 70s, late
I'm just
70s.
kidding. I'm kidding.
Yeah.
Oh, the games they
Oh,
used to send home in the 50s to the 70s were awesome. You get all kinds of cool stuff, man. You don't get any
Yeah.
of that now. Like, you can't even buy a lawn dart these days.
yeah, it was
Yeah.
like
Oh,
in the
lawn
back
dart.
of it was all that stuff you could it was a mail-in thing for like plans for free energy device, and it's
Yeah.
like on the back of Popular Mechanics or whatever,
Yeah.
right?
The old Sears
Even
catalog.
Yeah.
I think even Nexus magazine used to have it too, if I'm not mistaken.
The
Because
good old
I had
days.
a few. Yeah, that was mid 1980s when I had a couple of volumes there of a Nexus magazine, and they freaking canceled it. I was so pissed when they canceled that magazine. I
Wow.
love Nexus magazines.
I did
That's
Popular
the-
Mechanics, or Popular Electronics. I
I
did too in the early '90s.
I mainly did Popular Mechanics and Nexus. Those were the two I liked.
Very cool. What about you, Nathan?
Oh, I spark it up in my garage all the time. Are you talking about where I first learned it?
Yeah, when did you start this? That's a good question. When did you guys all start this? Let's call it a free energy pursuit or hobby. When did you start it, Nathan?
Like 4 years ago. I was bored in my retirement, and I just said, you know what? Let's do something different. And I had some old CRT TVs laying around, so I watched some things on YouTube, and I started sparking things up. Then I started
Wow.
buying equipment, started getting the understanding of things and how to build them.
Mhm.
And pretty soon I was just ripping things out of TVs and out of old VCRs and everything, every motor I could
Nice.
find. I took apart washer machines, dishwashers, everything, tried to rebuild everything everybody had on the internet and just see if I can reverse engineer everything.
Wow, that's cool.
Yep.
Very cool. It's 4 years. I couldn't tell. It seems like something you've been doing your whole life.
Well, you know how they say some people can learn in a school or they have the aptitude to learn.
Hmm.
Well, there's some people that can memorize stuff, and then there's people that can really learn it. I don't take notes in school. I never have, but I pass all the tests. I just
Wow.
have an ability to learn it and learn it fast at a good speed where it doesn't take long to understand it because I cut out all the garbage. You see me work. Like
Yeah.
I cut out all the noise and then I get to the point and then I stick with that point until, you know what I mean?
Yeah.
Yep.
And then that's it, man. I just have no time for all the extra words, the big words, any of it.
Yeah.
Yeah.
Block out the world and concentrate on what you're doing.
That's right.
Yeah,
Very
totally
cool.
focused.
How about you,
Yeah,
Mike?
I started 2004. I started making hydrogen generators for the car.
Nice.
Oh, wow.
So I've been at it 20 years.
How did you store the hydrogen and the oxygen?
I basically was able to create a huge amount of hydrogen, way far exceeding a lot of the stuff that's out there now. It has to do with the geometry of the plates, how close the plates are together, creating a cavitation event.
Mhm.
Also, at the time, I didn't realize it, but Philip kind of jarred my memory on it. Getting the water temperature up to about 50 to 60 degrees also increases output. And I would just
Oh, interesting.
take the tube out, put it through the bubbler, and after the bubbler, shove that tube directly into my the air intake where your air filter is that goes into the engine.
Hmm.
And that's where the hydrogen goes right in through there.
And
So I
the
had it in.
Mhm.
Sorry, go ahead. Sorry.
Well, you ran a motor from it straight from the cavitation?
Yeah, well, I had a pulse PWM circuit hooked up to it, so I was able to get it pulsing like a heartbeat.
Hmm.
So it pulse. Each pulse, I think, was about 4 amps or something like that.
Wow.
So I was able to control the frequency and duty cycle. So I was able to get the cell like pulsating like a heartbeat, right?
Hmm.
And I was able to generate enough of that hydrogen. I fed it right into the intake manifold through the air where the air filter is.
Hmm.
So I increased my fuel mileage by about 25 to 30%.
Ah, okay. Because hydrogen's very flammable.
Yeah. Yeah. It increases the heat. You have to do a little mod to your O2 sensor. I had it in a 2001 Pontiac Grand Prix GT, the 3.4 liter. So I
Mhm.
had to do a little mod to the O2 sensor to fool it, saying that it's getting the right amount of fuel. When I was actually decreasing it. Actually had to design the potentiometer to compensate for that change. If you get
Wow.
that right, that if you get that right, it fools the computer.
Wow. And that was an old car. So can you do that on a new car?
2001. New car is extremely difficult. The best
Yeah.
results I've heard, the best results I've ever heard were on diesel. So if you have an old diesel, they work fantastic on diesel.
Ah,
Yeah.
interesting.
So
Good
that's
info.
where I started. That's where I started. But there was a lot of stuff pre 2004 that something happened in my life that it kind of sent me in that direction in that journey. So
Yeah.
that'd be a 2-hour show right there.
Well, thanks for sharing. That's interesting. Yeah, I just got into this hobby about 14 months ago. Before 14 months, I couldn't spell Tesla coil. And so I retired early because of health. And I did electronics 28 years ago when I was in the military. And so I remembered some things. And yeah, I got hooked on it. And then I saw Nathan working on a Tesla coil. And I just put comments right in the YouTube channel comments, and then we got connected, and yeah, the rest is history.
Yeah, Sean told me he knew how to fix my Tesla coil because I was burning things up. Of course, you know me, I'm the king of that. I like to fry things. But he got in there and said he got the answer, right? So I go, okay, well let me ask him, right? And let's start a cut dialogue here. And then nobody knew the answer that he had until I saw what he did. And then I said, okay, expert level. Then old man builds down here. Okay. Has no chance of getting to where he is without his help. And that's about the way it went.
What really kind of inspired me, right, was at that time around 2004, I started doing conspiracy radio. I was really into the Art Bell show and stuff like that. I was really into that stuff and enjoyed it, right? And at that time, around 2004, podcasting was just kind of starting. So I was able to get a server going and actually do a webcast. And I had John Hutchison on my show twice.
Really?
Wow.
I had Jim Mars on my show twice. A whole whack of guests. Like a lot of people that was on Coast to Coast AM, I had on my show. This is around 2004, 2005. But the guy who really accelerated and inspired me and got me excited about the whole thing was John Hutchison.
Yeah.
He was really my turning point on, when he was talking about these crystal cells he was making. Like, wow. I was just
very
totally
cool. Sorry, I have a quick. Someone's asking a quick question. Sorry to interrupt. For 6 years, I was on a destroyer, naval destroyer, sailed around the world, served in the Persian Gulf War. I was an electronics technician that whole time. Then I got shipped up here to Great Lakes, which is about 40 minutes north of Chicago. I was a drill sergeant.
Far from me.
Made grown men cry for a living and sent them out to the fleet. I was a
so opposite of who you are right now.
Yeah, no one believes I was a drill sergeant because I have this sort of nerdy, boyish grin. But yeah, looks can be deceiving. And then I was a battle stations instructor where Chris Kyle, the American sniper, he went through my class.
Oh, okay.
And then I got out because they wanted me to go back out to sea for 5 more years. And I said, oh, no. Sea life is hard. Sea duty's rough. So yeah, stayed in the area of Chicago, taught myself how to computer program, and then worked at big pharma companies, worked my way up to global director of IT operations, and got sick and retired early. So yeah, thanks for asking.
Yeah, you have to have a hobby when you retire. That keeps your body going, your spirits up, and when you're really engaged in something that you really enjoy, it actually does a lot of good for you, your whole well-being, just mentally. And
great point.
if you're happy in your brain, your whole body's happy. That's the way I look at it.
Oh, you're
Happy brain,
100%.
happy brain, happy body, right? So that, like my father, he goes, well, what am I going to do when I retire? He's 83, right? And he still works at the church and works for the
Wow.
contracting for the company he worked for. Dad's 83 years old. Dad, call it quits. You know what I mean? Like, but he goes, no, I got to keep my brain going. I got to keep going.
Yeah.
So,
Yeah, it's good. This hobby is good for the active mind. And that's my
yes.
problem. I have an overactive mind. So this is a complex hobby. And I follow Nathan's rule, the 10 component rule. I can't do I don't want complexity. I'm allergic to complexity. I mean, some people are great at it, and I don't want to put them down at all. I envy them. I just can't do it.
You have to make you know what? It's good to have a coach, but sometimes making the discovery on your own is even better, because then you see, like, you could have a guy mentor you in the right direction. And then when you actually do the experiment for yourself and you actually see the result,
oh yeah,
see it for your own eyes, it makes it, the number one, the credibility of it. And number two, wow, it works.
Yeah,
right?
You're an expert too. By the time you get something complex working, you're just about an expert on that.
Yeah.
And you just build off it.
Yeah, the way you talk about your creations, Mike, is as if you were a Boeing engineer for designing jet planes, but you make it sound easy.
Like, as far as being a maker, I started at the age of 4. So I was a Lego fanatic. I wouldn't be watching TV. I'm with my Legos. What's Mike doing? He's on his Legos.
Wow.
That's where I started at the age of 4, and
right.
I've been building stuff my entire life. I've worked for military companies. I'm NATO certified. I could work for any NATO affiliate company, third party, whatever.
Very
I can
cool.
work for. I'm completely certified. So I've been building stuff my whole life, pretty much.
That's awesome. Only 14 months for me.
Doesn't matter. You can start anytime.
It is. It's great. I have no idea what half of you all are saying, but I just nod my head and agree.
You'll get there. I've heard it all so many times, but I always look into their invention. And Mike found this out. We did a live once, and probably the next day I'm sitting there on his channel trying to figure out exactly what's going on.
Yeah.
Because I don't like not knowing. So I went through everything, left comments. Mike was nice enough to get back with me on them, but I had to figure it out. I just can't let it go.
Yeah, that's the itch.
Yeah.
Yep.
Like like what was actually happening in my Renegade motor, it took me 2 years to actually figure out what the heck was actually happening in there. You think you know the answer, but it turns out you didn't know the answer. But I had to look in different places, and I was getting the most common. I was getting synchronicities between different sources, and then I'm going, reactance. Reactance is what's happening. But how does the piezo transducer enhance the reactance?
Yeah.
Right. So I had to figure that out, and then I talked to Salvador Paez, and I told him what I was doing in my motor, and he goes, "You're exactly correct. They go in unison together."
Interesting.
You put the coil and the transducer together, and you pulse a very high spike of voltage going through it. It will increase your reactance in the coil by 50%.
Interesting. Yeah.
Yeah.
Reactance goes up with increase in frequency.
That
Inductive reactance.
Yep. So
Yeah.
the question after that is, how do I use that?
Yeah, that's the thing. And the back EMF, and it just fascinates me how this free energy genre sort of focuses on the wasted electricity in systems. It's I lack of a better word.
Like say like a machine shop or a weld shop, they use a huge amount of reactive power. And guess what? The power company charges more money for reactive power.
Hmm.
You see? So, and Tesla even refers back to it. It's the driving force of current. It's the reactance in the coil. So,
What's the difference between the power that my light bulb here is burning up in watts and reactive power?
right. So reactive power will stay cold, okay? Because it usually reactance happens at a higher frequency, right? When you go down to 50 or 60 hertz, now your system is not really a voltage or a power based system, it's an energy based system, meaning it needs current to drive it. The more current you have, the more heat you have.
Right.
Hysteresis also takes place. So when you
Right.
use a huge amount of current through an inductor, you're going to have hysteresis. So if you want to learn about that, the best guy to read about is Charles Proteus Steinmetz.
Yeah, I've heard of him.
Yeah.
Yeah, it
Very,
makes sense.
very.
Toy Maker always talks about him.
Yeah, he started the GE electrical engineering back in the early 1900s. So,
Oh, wow.
so if you really want to learn about hysteresis, reactance, any system that Tesla created, Steinmetz was able to engineer it with the math that go behind it and make those systems work to the point of deployment into industry without it
Hold on.
blowing up.
He's also the guy that took out all the back EMF, everything that's special in every one of our systems. He's taken out, and he just made it a basic generic system that works.
That's right. That's right. And he was deliberately told to engineer it that way. He had several books that he was going to publish, but GE said, you're not doing that. No. And they put a block on some of the stuff. He was kind of suppressed himself. So a lot of his stuff, I think, tailed back to what heavy side component. So
is there a book that
no,
puts together his theories?
you might be able to dig something up. As far as I know, GE and the powers to be really blocked him on publishing that stuff.
So how did you learn about him? If do you have the books
Well,
that are out of publication?
the basic stuff. Well, when it comes to reactants, when it comes to one of the most famous devices he invented was called the dynamotor. So that's one you can look up. You'll be
Dynamotor?
totally yeah, it's called the dynamotor.
Okay.
So basically, when you have, say, for example, a power grid, there's so much available power in the power grid that it used the power that was in the grid to power the generator. So long as he kept those coils energized, that generator would work like a motor and create more power to add to the system. So he had so much power in the grid, he didn't have to have an exterior power source to run it. He just ran it off its own power source.
So when I bring my fluorescent light bulb close to my Tesla coil as it's sparking, arcing and sparking, I'll look at the amps used, and that fluorescent light will be robbing amps as I bring it closer to the coil. How is the power that's being radiated in your scenario not really increasing the amps somewhere else?
That's a very good question. I have to think this one out properly. That's actually a very complicated answer, but a very good question.
Thank you.
Because it is radiating power that's creating electrostatic, right? So that's filling the space. Now, if you're sucking the electrons or the static field from that space,
Mm-hmm.
the coil or whatever device you're using to create that static environment now has to charge more electrons in that space.
Mm-hmm.
So that puts a heavier draw on the system to keep up with it, right?
Yeah, that makes sense.
So that could cause problems with heat. Like I said, if you start drawing more amps, you got more heat.
Oh, of
If
course.
you got hysteresis building up in your coils in your circuit, then now you're going to be drawing more current from your power source. So it's now being more of parasitic, power draw.
It's a cascade effect. Mm-hmm.
Yeah, it just starts breaking down. It's all part of the hysteresis involved, right?
Okay. Mm-hmm.
But the other one was what was the other second part to your question?
Just that when I bring the fluorescent bulb closer to the Tesla coil, I'll
Right.
notice that my amps from my power supply go up. So it draws more amps, even though I'm 2 feet away. And then if
Right.
I pull the fluorescent light bulb further away, it uses less amps for the same discharge of sparks.
Right.
So when you were mentioning about all the power in the air, that radiant power, when you bring some kind of something like a light bulb to it and it lights up, is it increasing the amps in the system?
Your capacitance. Your hand will do the same thing to your Tesla coil.
Yeah.
When you put your
That
hand,
changes frequency. It doesn't increase current though. Increases current as you rob it with a light bulb or something.
you're stopping it from oscillating at the correct oscillation, so you're getting more amps drawn into it. That's why it fries.
Right.
Mm.
Yeah, you're creating a resistance. There's a resistance there.
Oh,
and the
interesting.
resistance. So when you put a resistance in on the way out, it's going to create a differential, and it wants to correct itself by adding more current to the system to make up for that, resistance, right? Because any resistor, if you put enough power through it, it heats up. That's where
Yeah,
hysteresis
changes it
breaks
to heat.
down.
Yeah, changes it
Well,
to heat.
you're lowering the frequency. As soon as you're lowering the frequency, the amps go up.
That's right.
Mm.
So you have a direct correlation there of what's going on. You're changing the voltage and bringing up more amps every time you change that frequency.
Yeah, I've always heard you speak of that, Nathan, and I really, it's sometimes tough to wrap my head around it, but it makes sense. Capacitors and inductors or coils, they are frequency dependent. They have different reactions to frequency. Frequency goes up, and then it has a domino effects on the coil and capacitor. Or if you increase capacitance, it has effect on the frequency. So they're all tied together.
That's why I tell people I could take a cheap dollar store wire and run that ZVS off of it instead of making a thick battery cable, because I have it oscillating so perfectly that it no longer needs it. It'll push everything out right away, and it doesn't cause any feedback.
And so you're saying that you could run more power through that thin wire because of the efficiency?
Yeah. It doesn't have time to stop and heat up.
Interesting.
It's like a vacuum.
The other thing too that will increase your current going into the system would be your inductance, right? So if you take like a coil that has a core, right? It's going to create more inductance in that coil and want to draw more current to create the field. But if you take that coil or the core out of the coil, there's less inductance. So now you have the advantage of boosting up. Current will go down.
Interesting. Yeah. Interesting. This is all good knowledge, guys. Good information. I'm going to turn into a pumpkin here pretty soon.
Yeah, it's getting late. It's about 3 hours in.
Yeah, I appreciate everybody in the chat. And Mike, awesome stuff. Thank you so much for sharing.
Yeah, it's kind of hard to explain some of this stuff sometimes. It's almost like you have to show a demo to kind of get your point across. But
Yeah, sure. But you made some good sense and you helped me.
yeah, I'm not the best at describing. Sometimes it's a little hard to describe. You have to actually witness it.
Sure. No, you helped me a lot. I appreciate it. I wrote down dynamotor, hystereses, and Steinmans.
Steinmetz. Charles Proteus Steinmetz.
Hey, V Sears is checking in. He's got himself 2 DVS units.
Awesome. Can't wait to see what he does with them.
Yeah.
All right, gentlemen. It was a pleasure.
Right on, guys. All right, guys. I want to thank everybody for showing up today and being in the chat and hanging out with us. Thank you to Sean Calderon on presenting today. Thank you for Mike Faraday. Thank you for Gerald. Thank you for Jeremiah. And oh man, thank you everybody for coming into the show today. I really appreciate it.
Yep. Thanks a lot for having
Take
me.
care, guys. Cheers.
Yeah. Cheers. Have a great night.
Thank you. Bye.